Hello, everyone, and welcome to Kube Simplify. Um my name is Sayam Pathak, and in this particular session, we'll be diving into observability. So, I know it's a weekend, 4th of July, and it will be a few hours of a workshop, a hands on workshop, and we will be diving into the observability concepts. So please mention in the chat from where you are joining in and how are you doing? What are you learning these days? So, first of all, thank you all for making out time for this particular workshop. And I'm really excited to bring Manoj, who is one of my close friends as well. And he will be walking you through the entire observability workshop. I think he has timed it to around 3.5 hours, which is good. And we'll take a break in between as well, so that we have the right focus on. Um, so there will be something which is called playground. So there are multiple options that are there to do this particular workshop. One of the workshop is sorry, one of the playgrounds is you can use any of your Kubernetes clusters. So if you already have a Kubernetes cluster, and it can be local, it can be on any of the cloud vendors, then you can try to use that as simple plain Kubernetes cluster. We also have partnered with Ivan, who is the founder of Eximius Labs, to get some playgrounds for us, so that of you who do not have the playground kind of thing or a Kubernetes cluster, they can kind of try it. So we'll be sharing all the links once we get to that particular point, and the joining instructions, like how to do it. It's pretty simple. You don't need any stuff. It will be based on, it is browser based. And before we start, a few housekeeping items. Make sure that you are good to each other in the chat. So I usually follow the CNCF code of conduct. So similar kind of thing applies to this as well. Very simple. Just make sure you are nice to each other in the chat. And so good to have you all. Okay, I have these, so I'll just pull you up on the screen as well. So good that so many people are already here. I'm just adding you. Mexico, Noida, Prayagraj, very good. London, thank you so much for joining in. Awesome. So good to see you all. And the main thing is that this particular workshop is live, and we want to make this interactive. So the more questions you ask, the better it is. That's the whole point, because you people have taken out time from your weekend to attend something, and this is the whole purpose of the workshop, because the recording will be available later on, just in case for anyone who because many people want to learn, but the time doesn't allow, or the time is not right, whatever that is, so that they can view. But since you will be joining, you are joining in live, so you can actually work it out, and you can actually ask questions. That's your biggest advantage, and that's the biggest advantage of any live stream out there. So in this particular live workshop, I would want everyone to be very interactive in the chat, and keep sharing, like whenever the instructor, like whenever Manoj asks, if has anyone completed this, just raise your hand. Yes, we have completed this. Try to do it step by step. He'll be definitely sharing you the repository structure, what you have to clone, what you have to run, all the command. He has prepared a very nice GitHub repository already that he'll be sharing, so that it's easier for you to copy paste the commands as well into your terminal. And yeah, apart from this, make sure to subscribe to KubeSimplify. I always forget this particular thing. So make sure to subscribe to KubeSimplify YouTube channel. If you are watching this later on, if you are watching the recording later on, please subscribe to KubeSimplify. That helps us keep growing. And also, I'm sharing a few links so that you can join those as well. So this is one of my newsletters that I post daily. So if you feel that you are missing out and you do not want to scroll socials, you do not want to scroll X, you do not want to scroll LinkedIn, and you just can give 3 to 5 minutes of your time, then this is the newsletter that I publish daily, so that in 3 minutes you can actually work it out. Like, you will be able to get all the news in the AI infra, AI and the cloud native ecosystem. So you will be able to get up to speed on what is happening in the world. And then obviously KubeSimplify YouTube channel, please subscribe to that, and all our socials. And if you like anything from this particular workshop, feel free to take a screenshot, post on your socials, tag Manoj, tag me, tag KubeSimplify, and also follow Manoj, add him to your LinkedIn, make sure you are connected. Let me bring him to the stage. He's already here. So tag him and tag us that you learned something from this particular workshop. That boosts the instructor confidence more. And based on the success of this workshop, there are a lot of topics to cover. So based on the success of this workshop, we'll plan what to do next. Because we here, as mentioned in our page as well, on my social post as well, this is a beginner level workshop. So we start with the basics, and if the response we get is amazing, then definitely we are open to do more complex workshops. And if you want to see a gist of what can be there, what workshops and what pipelines we can build, you can watch Manoj session at KubeCon India that he recently gave. The recording is already out there, so you'll get a gist of where we can take things to in production. So that's about it. That's about KubeSimplify. We took some 8 minutes of time, and now I'll hand it over to Manoj. Manoj, very warm welcome to KubeSimplify. Thank you so much for doing it on a weekend, and very happy for you to be here. And thank you so much for joining in. And I give it to you from here.
Thanks, Sam. I hope my voice as well as the video is clear enough
Yep, all
for
good.
everyone. Yeah, thanks, Sam, for giving me an opportunity to share what I do on day-to-day basis. Observability being my passion from almost last 5-6 years. I started from zero, and I know many of you might also be starting from zero. And that's where the whole motivation of this workshop is the people who are actually starting from zero, how to kickstart in a real speedy manner, actually. So yeah, as Sam told, right, you can use your own Kubernetes cluster if you have. Otherwise, there will be a playground provided soon when we start the workshop. So I'll not waste much time and just get on to the introduction and in the start of the workshop. Let me just present. Okay, I'm just sharing my screen.
Manoj, if you can just remove the blur from the camera, it might look even better.
Okay, let me see where the settings are. I may have to figure it out where the settings are.
So if you click the little arrow beside the video icon, and then the settings,
Yes.
and then the effects, and then
Visual effects. Okay, visual effects.
and do it none.
Okay, yeah, I see none. Okay. I hope it's
Perfect.
better.
Yeah, now looks very good.
Okay, good. Okay, no background. This is my room. So, okay. So, and that's where whole observability get done for SQL software from this room. So anyway, so I hope my screen is visible to everyone. Sia, maybe you can just confirm.
Yeah. Screen is there.
Okay, so let's get started then. So, I'm already introduced. My name is Manoj. I work as DevOps and observability lead within with SEL Software in Noida. As I said, observability is my passion from quite some time now, and I'm enjoying it to the full extent, actually. Uh, so let's get started and see how we move. I split the whole workshop into four sections. Summary, just to interact a little more if time permits. Into four sections. Each section has a lab attached to it. The first two are a little bigger one, and both of them has couple of labs attached, and the last two one is a little simpler one. I will not say simpler one, but because you have made a foundation in the first two, the other one takes a little less time because you already have some basic understanding of what we are doing. So in most cases, you will see less than 50% time spent on slides. I will even reduce it to maybe 20 to 30%, and rest of the thing will be on the workshop. So in the first to 45 minutes sessions, maybe 15 minutes, 10 or 15 minutes on slides, and the rest of the time we will actually start doing workshop. In a workshop, while I have a Git repo, I will share that link. You can clone that. Most of the artifacts required, scripts required are part of that Git repo. You can copy paste. But in some cases, I will recommend you start making changes manually by yourself because that gives you more confidence, better understanding of the concept which you are covering. Copy pasting, might miss some of the attributes actually which is getting added. So I will clearly tell whenever I think you should be doing something manually and not just copy pasting the file and running it. I will keep telling that. And of course, when you copy paste, there will be some errors. You might get some YML issues, some indentation missing, or something of that sort. So we need to make sure that we are doing it in the right way. Okay, the first topic, we'll talk about basic monitoring. We'll talk about little bit about Kubernetes monitoring, how generally people do currently, especially the people who are starting now, how they try to monitor. Uh, Attached workshop are that we will actually set up the foundation. We will set up an application called OpenTelemetry demo, and then we'll also install Prometheus server. That is where everybody starts when they start observability thing. They generally start with a Prometheus server first, and it's like a very basic hem install, and you start using it. Everything is out of the box, but that give you some foundation. Uh, we'll follow up with the second session where we will try to jump from a traditional Prometheus based monitoring to the modern OpenTelemetry based monitoring. We'll try to see how an existing setup of Prometheus server can be moved to OpenTelemetry pipelines. A little bit of a migration concept, how you do it. Uh, when we do it, we will, because Prometheus is only for metrics, we will do it for metrics, and then we'll add on by to another session to the same open telemetry. We will add traces, we will also add logs. So end of the day, you will end up with a open telemetry running with all the three signals getting captured. No third-party tool we are using. Mostly it will be Prometheus, Jaeger, or OpenSearch. Three different tools for three different signals. But that's just a start. You can actually do it in a single backend also, which support all the three signals. Okay, let's get started on to the first. What's monitoring? You guys can also put your response into the chat, and I request Sayam maybe they can actually start looking at the response, how people think the monitoring is. From me, the monitoring is a kind of a collection of some signals, something which is
Oh,
happening within the
sorry to cut
application. Yep.
sorry to cut you, Manoj. If you want to take a poll, we can take the poll as well. Like if you want any polls to be taken, I can generate a poll and create a poll just in case in between. Second thing
Sure.
is any link you want to share, you can just message me in the private chat and then I can share that link whenever you want to share.
Sure. So I may have to change my sharing setting then because I think I've shared the whole screen. So we'll change that.
Yeah, you can just
So
ask me and I can remove your screen. Then you can switch, send me the link. You can switch back and then you can
okay,
ask me
okay,
again
okay,
to
okay, okay.
access you.
Sure, sure. Okay, so I'm not. If you're starting right, the first level of monitoring which you talk about or people think about is something related to infrastructure. You just say, okay, what is my CPU? What is my memory consumption? Right, that's the basic thing which everybody starts. For me, any signal which actually indicates the health of my system, it can be CPU, it cannot be CPU. I mean, depends. But any signal which indicates the health of my system is monitoring. So you capture all those signals which you think will impact my health of my system. You capture it, you analyze it, and you store it, and then you actually make use of it for analysis. So these signals can be anything. When we start, the basic thing, most of these signals are actually metric. I mean, we don't, or maybe sometime logs. We just think of metrics and logs, two type of signals. Metrics mainly come from infrastructure, where you will talk about CPU, you talk about memory, you talk about disk usage, you talk about network bandwidth usage, file system usage, your cache usage, all that stuff you use. And when it comes to logs, logs are generally attached to your application. So metrics generally get attached to your infra, and log that attached to your applications. And these two signal combined gives you some information about the health, and that's what we call it as monitoring. We capture it, we store it somewhere, and we do actually analyze that. But that's not exactly the observability is. What we talk about only monitoring. So this just gives you a kind of an errors, which from where we started and from where we are, and of course we are. It's not the end. There are more modern errors will come beyond that, related to AI and other stuff. But yeah, we started with something just saying, is my VM machine up? Is it responding? I mean, that's the only thing which we say. We generally do ping our machine through a URL or something and say, okay, this is up. That's from where the basic stuff started a long back. We moved to application monitoring. We added logs to it because now logs gives you a health of application. So you do that. Then come the cloud. There are distributed system, networks coming into picture. That means because there are a lot of moving components now, you have hundreds of microservices running, small middleware, middleware running. That means you now need to even worry about their interaction. So those the network thing comes into picture. So you start monitoring network. Then it comes the Kubernetes that changed the whole thing. You came up with containers. Server is no more the single one. There are hundreds of application servers running within the same virtual machine or same. So that means now you don't need to just talk about network. You also need to talk about how many servers are running and how they are interacting with each other. Who is calling whom, right? It's just not only basic networking. You come up with a Kubernetes networking also. I mean, which pod is interacting with which pod, right? So that's come the next. Because there are multiple components involved and each is calling each other. I mean, there is a complex mesh now there is a need of seeing where the whole request is going through, how many components a single user request actually go through. So that's come the concept of traces. Without traces, just by logs, looking at logs of hundreds of microservices, it's become very difficult to trace the whole request. In monolithic, it was easy because there is a single server. You can actually, and the logs contain the whole history of each method call, everything. But now, even your logs are separated, right? Each microservice has its own logs, log standards, and the way they are writing log to the console, it's very difficult to stitch together everything. And that's where the trace coming, the fifth one, which comes when the trace is coming. A lot of vendors actually start building their own way of building traces, and there's no standardization. Each vendor actually end up doing their own way of tracing, and switching become very difficult. And then the sixth era OpenTelemetry came in. We try to standardize everything, all the signals, metric, traces, and logs, all three together in a way that no vendor can lock you in. So you can actually use the same agents or same processes to actually take this signal and put it to any backend. So that's where the open test. So we are at the sixth. Of course, there's the next era, AI ops and other things, self-healing, lot of things which are building on top of open telemetry, and I'm sure they are not far away. Okay, so Sam, just let me know if there are any question in the chat on any of these things. Maybe I can stop and respond to that.
So, Manoj,
So
there is this, if you see StreamYard.com sharing, can you click hide over there?
just sorry, let me see.
Yeah.
Hide. Yep.
Yes.
Yeah.
Perfect.
Okay. Yeah. So now when we understand, right, how the monitoring actually came from zero to now OpenTelemetry, one of the basic concepts which comes across all the agents which we run is the pull and push based model. And if you understand this, a lot of complexities, lot of issues related to any agent, is a Prometheus or it's an OpenTelemetry or any other agent, a lot of things get clear out how things works. Uh, Initially, right, in the era 3 or 4, when we were only talking about metrics, we always talk about Prometheus. Because Prometheus is really great in getting those metrics pulled. So when I say pull or push model, this is in context to the agent who is actually capturing. So when I say pull-based model, as it says very clearly, agent pulls it. Pulls it from where? Pulls it from a source. And why? How it's pull it? Source actually expose it on an endpoint. Is it not pushing it? It just give you an endpoint and tell you, if you want metrics from me, just call me on this endpoint and I will give you the response back, the all metrics which I have. And that's where the Prometheus shines. It actually create jobs. It actually discover all those endpoints which various applications, infrastructure, or any other component is exposing, and it actually scraps with an interval, 15 seconds, 20 seconds, 30 seconds, whatever you fix it. So every 20 seconds is pull it and actually make use of it for any analysis. So where the responsibility lies now, the responsibility of creating those metrics is with the application, whoever is trying to expose. Creating that endpoint or the REST API, it's with the application. Agent only know I need to scrap, I need to call this and get the data, and it do it every some interval, 15, 20 seconds, whatever you want to say. That's the pull based. What's the push based model? So here the responsibility of just not creating the metric, but as well as pushing it to some source to the agent is also responsibility of an application. That means application has to have a logic, just not to create, but make a call to some agent, some post call, and post it to the agent. It's not, nobody's pulling it. It is responsibility with the central system or the application to push it. Now this central system need to know, right, whom to push, right? It doesn't know the endpoint. In case of the pull model, Prometheus discovers those endpoints. There are a way to discover, and we'll talk about that. But in case of push model, the application need to know whom to send, and it does not have any discovery mechanism. Most applications which we write, right, they are functional. They are what the business problem we are solving. We are not going to write how to discover those endpoint to push, and those then those endpoints are given as a environment variables, as a configuration to the central system. Okay, this is my endpoint, push it to this, and that configuration is pushed by somebody to the central system. Who is that somebody to push? And that's where SDKs come into picture. So there is an SDK which get put as part of the application itself. It owns the configuration. It owns the responsibility of sending those metrics generated by application to a agent. So in the first model, application only responsible for creating metrics and exposing onto the endpoint. In the second model, application is responsible for creating and sending, not just exposing. And sending is done by a separate SDK, which become part of your system, and it actually responsible to get those stats collected and send it to the backend. So that's the difference between pull and push. And there are a lot of issues which comes when we try to do collector pipelines and all are depend on these. If my receiver or is my source is a push, is following push based, or it's a pull based model, and then a lot of configuration start making sense when we understand that. Okay, let's get to the next stuff. Kubernetes monitoring. Everybody understand that. I don't need to go much into this. Everybody understand there are nodes, there are containers, there are objects, there are events. You have a kubelet running in each node. This kubelet is responsible for exposing data related to container resource usage, CPU memory usage and all. And then there is a Kube state metrics. That's a separate deployment, but that actually call Kubernetes APIs and expose information about the state of the object. Is my pod running? Is how many replicas it has? Is the replica, I mean, required replica is equal to the current replica, and all that things it do. And then, of course, there is another thing, event metrics, which actually expose those events which can be scrapped. So yeah, so Kubernetes comes up with its own way of exposing data through kubelet, through Kubernetes API, or through the event metrics. It actually exposes that data, and somebody has to collect it if it want to do. You have a kubectl top application thing, which actually make use of these setup to actually show you CPU memory usage of for pods and nodes, and it actually do it through kubelet. Kubelet actually expose it, these metrics, and kubectl top CLI actually make use of that endpoint to get that value and showcase it. And we will see this in our demo or in our workshop. Okay, what is Prometheus? I think we talked a lot. It's a pull-based model. That's why I talked about pull and push-based model, because I wanted you to understand what Prometheus is. Prometheus is a pull-based model. That means it has to discover all the endpoints, and it can scrap only those applications which are exposing metrics on an endpoint. If some application is not exposing, it cannot collect anything. It's not a responsibility. Creating is not a responsibility of Prometheus. Prometheus' responsibility is only to collect data which is exposed by applications. We'll talk about more onto this, how the service discovery happens, what is the time series database as part of our workshop. So I will not spend more time into this. We'll talk about the Prometheus configuration, job configuration, and everything as part of the config we built for Prometheus. Architecture,
Manoj,
again, yep.
Sorry to cut you. Just before we move to the next part of the Prometheus architecture, there are a few questions, and I think the more interactive it is, the better it is for you and the audience.
Sure.
So one thing was when you describe the observability pillars, there is one more thing which is the profiling, like how the profiling. So can you give a little bit of insights? Like I can also provide. So basically, profiling is getting you the exact information on. Oh, sorry, my camera is off. Yeah, so profiling gives you the exact information of your resource consumption from a particular function of your code. Like it goes to the actual code level rather than a high level metrics of that this is using 4G RAM and stuff.
Yeah, the same. We will touch base on that when we talk about OpenTelemetry in the second part of the session. I mean, we are just talking about the basics now. I will come to, because I have a slide deck completely to explain all the pillars, the 4 pillars which we are covering. Yeah.
So I hope that covers your question. And then can you explain traces in a simple way?
Okay, that's again the next section. I think we are jumping to the second session. We're talking about the basic monitoring. We will come to traces and profiling in the next.
So Chitranjan, just hold on, and your question will be answered very soon, because there is already a slide that he has. One more thing is you talked about exposing a metrics and then endpoints. So Rajan asks, like, what does exposing metrics at an endpoint means? Like, how does the expose work?
Okay, I mean, it's a great question actually. So when I say expose, it's nothing but an API get API endpoint, nothing else. So if I say get, let's say /metric, I have an endpoint for my application www.abc.com/metric. That's the endpoint. If I call this endpoint, in response, it gives me a set of attributes, key value things, and that's a Prometheus format in which it has to come. So this is very simple, like a property file, key value, and we'll see that when we talk about Prometheus in our workshop. So when I say exposing, that only means creating a get API, and if I make a get API call, my application logic is written, which will send me some key value pairs. This key value pair is nothing but the signal. It's something, let's say, I'll say, give you a very basic example. I put this call that, and my business application is exposing how many order has been placed today. That's it. That's a metric. So whenever I make /metric/order, it says 20. orders 20, and you can even go into more details. You can even say order of item 1 10, item 2 20, item 3 20, because you have hundreds of items which you are selling. So that's become exposing your business metrics on a get endpoint. And then Prometheus can actually make call to this API every 15 seconds and show you a very great visual graph of how many orders are being placed today in a very visual graph. So, okay, in the first are 10, in the second are 20, in the third are 100, in the fourth are 10, and you will actually see in which place you number of orders are higher. I mean, you can analyze that. So that's how it works. I hope that makes it clear.
Great, thanks for that. I hope it answers your question, Rajan. And one follow up on that is, so is the pull based model more suitable for k8s monitoring?
Okay, so very controversial question actually, and in my past 3-4 years, I have talked about both. I mean, some places pull is good, some places push is good. It depends. And when we come to an open telemetry, right, we'll talk about both, because open telemetry collector support both pull and push both. Because I will not say wave one onto the others. It's based upon your use case to use case, right? The modern applications which are being written currently, they generally prefer push, because we are pushing instrumented to the left. Developer is responsible for instrumentation, and they can instrument and do a push to any endpoint, any metric. But I go to a legacy system, right, where it's very difficult to instrument the code now. They generally create an abstract layer on top of their code and prefer push model. I mean, the Prometheus type model, where I mean pull model, they just only expose. So it depends on use case to use case. I will not wave one onto the other. That's the whole reason why OpenTelemetry, the modern one, support both. It doesn't prefer one or the other. It depends. You can create any of them. So that's what I will answer. But I don't think it's very difficult to say one is better than other.
Awesome. Cool. Thanks, Manoj. You can continue next.
Okay, sure. Thanks. So Prometheus architecture, again, when we talk about config, right, we'll have more detailed discussion on that, because on the left-hand side, if you say I'm talking about configuration, because configuration is what defines everything. It defines how to pick targets, how to pick applications or the endpoints. Once you filter that out, it creates jobs. Jobs is nothing but some processes, some threads, which will actually, or a cron job kind of a thing, which will run every 15-20 seconds, make call to those endpoints, get that data, do whatever the formatting it has to do, and then send it to the backend. So you discover first, then you create the scrap jobs. When the scrap jobs are created, they pull up their targets and they start making calls, and every whatever the configuration you put on the interval and send it to the backend. That's whole the Prometheus server. But this stuff discovery thing, right? It's very strong. I mean, we'll talk about it more, but it can do a lot of magics here. So we'll do that about. And of course, when you put into the backend, it can be anything. It can be Prometheus, or it can be Grafana, or any other. And you can actually run PromQL. That's a SQL type language which allow you to query these data which is being coming and stored into a time series database. You can query that data, something like similar to SQL. Again, we will do some hands-on on Prometheus PromQL in the later stage. Okay, that's all for this. I think I took more time than what I thought. I thought 15 to 20 minutes. I think that's okay. So the next 20 to 25 minutes, we will do these two labs, 1 and 2. First, of course, you get your playground. We will deploy an OpenTelemetry demo application, and then we will try to install and the Prometheus server. And then we'll try to open Prometheus server UI and play with some of the PromQLs to see what data is coming. So over to you, Sayim. So maybe you can just brief how people can get their playground now.
Yeah. So, folks, the thing is, we have limited number of labs. So there can be like 40 to 50 labs that can be created. I see there are a lot more people over there. So if you please have your own Kubernetes clusters, then make use of those Kubernetes clusters. Or there are other playground options like Killer Coda that also you can use. Also for this one, I don't know how we can make it, but let's try to do it in batches, like 5 minutes or maybe 3 minutes 10 people are doing, and then next 3 minutes 10 people are doing, and next 3 minutes 10 people are doing. Otherwise it will be a spike. I mean, right? We are talking about the observability over here, and when spike occurs, no one likes it. So what I'll do is, yeah, Minikube, any cluster is fine. So any Kubernetes cluster is fine. If you have the resources, see, that's the beauty of Kubernetes. It's agnostic of what you're doing. If it's a Kubernetes cluster, things will run. So let me share you the training link first, and then you can start joining it. So first, you need to join the training. So I'll send you the link, and then I'll see over here. You folks will be automatically enrolled. So that's the link. So please join this training, and I'll side by side look at my dashboard. Who have joined? So we have roughly 40 to 50 seats. I know there are more folks, but at least 40 to 50 folks will be able to provide the playground. For the others, I'll also share a link called Killer Coda that you can use. If stuff doesn't work, at least it gives you a 1 hour of playground and 2 3 labs you can easily pull it off. All right, going to my dashboard and seeing some students getting enrolled. Very good. I already see 12 folks. So those 12 folks who have actually done it, scroll down in the training and you will find a playground link. So I'll just share my screen as well. So this is the training that you would have seen. You have joined training, you see leave training. This is about the training, and then you will be seeing a playground link. So just click this link, and then you will be seeing something like this. And every user will have a OTP kind of link. So since I am a logged in user, so try to understand this. I am a logged in user. I have an account. But when you join the training, you will get a playground with OTP link. So you can paste that in the browser, and you will be able to run like sign in as a temporary user. So you can sign in as a temporary user, which is totally fine. So sign in as a temporary user, come back to the training, and you will be able to then click on this particular link which is there below the training. So I'll just go once again, come back to the training, and then click on the playground link. So I'll open it in a new tab, so that, and after that you just need to start the playground. I won't start the playground because I don't want to consume all the resources. I have my clusters, but then you need to start the playground. So click here, start playground. So click on start playground, and then it will run a series of checks, and it will give you a control plane and things. Actually, I can start a playground to just show you that how it looks like, so that you understand. So it is booting, warming up the playgrounds. So we have a control plane and 2 nodes. So it's a kind of a 3 node cluster where one is control plane and other 2 are the worker nodes. So it is warming up. Awesome. Awesome. We have Sagar control plane and node 1 and 2 setting up. Amazing. So that's what we want. If you have already things getting warmed up, please post in the chat that things are getting warmed up. And this is how it looks like. So kubectl get nodes. So everything is there. So soon you will be seeing nodes also ready. So we have all the 3 nodes ready, and we are almost ready to do the workshop. Manoj, meanwhile, you can share the GitHub repository link. I can also put that in the
Yeah,
chat.
sure, sure, sure.
Also have a coffee and getting warmed up. Very good. That's good. I'm using local setup. That's perfectly fine now. It's up for Siog. Amazing. And I am sharing you the GitHub repository link as well, folks, that you can clone it. If you can pin. Okay, I'm pinning this on
And,
the chat.
yeah, and we will be cloning it in our playground also, because we need all those files in our playground also. I mean, you can of course locally clone it. If you are trying out things in your own cluster, you clone it locally, and people who are using the playground, we will clone it as part of the playground also.
And great that a few of you are already using what you have. Thank you so much. Like someone is using GCP, someone is using their own Kubernetes, which is what we want. And yeah, that's what it is. So I hope you went to the training. There was a link of the training. I can put the link again just in case. So putting the link again, go to the training, join the training. It gives you the OTP link. Paste that OTP link, sign in as a temporary user, come back to this workshop, go down, click on the playground link. It opens up a page where you can just use start playground, and then you will be finding a 3 node cluster. Just in case in between the workshop you feel you are not able to continue, or you don't have time, or you have other commitments, then please click here and destroy the playground, so that the resources are back to the pool and other people can consume it. So that's what start playground. So I hope this particular thing is clear. Manoj, I'll hand it over to you. If any questions, I'm still in the chat, happy to help in the chat. Any links, anything that is needed, I'm happy to help in the chat, and I can hop on the call as well. And also we'll do a live Q&A in the end for some time, where I can pull in some people on StreamYard. So one by one, we'll pull in some people on the StreamYard and we'll ask questions just in case you have. That's the beauty of uh, being an online webinar. And it's a kind of, I believe, a perk when you join a workshop live. So you need to get some perks. And one of the perks is you get the playgrounds, you're doing it live. Second perk is you'll be able to ask the questions live.
Yeah, thanks, Ayam. I think one thing which I just really like to emphasize, playground get expired if you don't run any command for next 15-20 minutes. I think 20 minutes, Ayam, right? I think 15 or 20
Yeah,
minutes, something like that.
15, 20
So make
minutes.
sure if you're using, you are running something, even because in between we might have some 15-minute session, right? 15-20 minute session. To make sure that you run some kubectl command or something of that sort to make sure it remains alive and does not get lost. Yeah. Okay. I'm not sure if everybody got. Maybe just mention in the chat if your playground is still booting up, because I don't want anybody to miss things out. We'll just wait for a minute so that everybody has their playground up and running.
So we have a Discord that you can join just in case you want to keep the conversations active and ask questions. I'll pull in Manoj as well to the Discord after the workshop. If you have any questions, you can ask in the Discord channel and he'll be able to answer. The second thing is obviously this thing. It takes some time. Like someone was asking how much time it takes. It takes a little bit of time to warm up the playground. Obviously, there are some pre-checks, and you understand, like 40 people continuously doing it. So it takes a bit of time. So I'll give it to Manoj. Manoj, also, if you can do Command Plus so that the font is a little bit bigger. That would be good.
Yeah, I just shared my screen. Sayam, if you can see if it's good enough or
A little bit more. So if you go there, yeah, perfect. One more.
Okay. I hope this is good.
Yeah, one more font if you can increase.
Okay.
This is perfect.
Okay. Okay. So just let me know, Sayam. I mean, if everybody is up and running, or anybody actually still waiting for their playground to apply. I think it takes only a couple of minutes, not beyond that. So hopefully everybody has their playground up and running now. Okay, so we'll just get started then. First thing what we will do is, like I think Sam already shared the Git repo. We'll just clone that. People who are using their own Kubernetes cluster, you can clone it on your local system because there are some hem files, value files, and scripts which you'll be using from that. And the people who are using the playground, they need to have this clone on their playground system, because you are working on a different node altogether. So you can actually copy it to any of those. So I will just make use of node 01. I will not use the control plane stuff just to be safe that I don't miss anything on control plane. I'll just do a git clone on this system. Okay, so if you go to repository, right? So there is a, I hope my, I'm not sure if I've shared the whole screen or only the tab. If it's a repo thing up seeing, then it's good. Is this,
No,
I feel,
on
okay, let
the
me,
screen. We're
okay,
only
let
seeing
me,
the, yeah, now we
okay,
can see that.
yeah,
Now
okay.
we can see that.
So this is the repo. In that repo, you have a README file. It actually covers the whole workflow, which we are going to do. There are around 6 labs till the end, and all labs have some. And these are not the only commands. These are very important commands which we will be running, but we will be trying out some what you call live commands also. Try out something new out of it. But these are the one which is mandatory to run the workshop. So first thing first, I will just do the clone of this thing. So I just copy pasting the command just to make sure we are not doing any typo mistake. So I'll just do the git clone my repo so that it clones it. So I got it in my observability workshop folder. The observability workshop folder has the README also. You can see it from here if you're not cloning it on your local system, or you can look at from the Git portal itself directly. And you do have hem. So there are 3 type of hem: hotel collector, hotel demo, Prometheus. We will be using one by one. Hotel demo and Prometheus is the one which we'll be using for this workshop. Hotel collector is for the next 3 workshops we'll be using. First, we'll deploy a hotel demo application, because before we start monitoring anything, we need to make sure there is an application running so that we can monitor that. Hotel demo is an application which is an official application from Hotel Collector. This is being used by many vendors to do their demos and all, and it has basically everything. Whatever new comes in OpenTelemetry Collector, they actually put in something related to that new feature as part of the demo, so that people can actually demonstrate the new things. So installation is quite simple. If you look at those README files, the next command is to add hem repo, and then do an hem install. So second, third, and fourth in the README after the git clone. So I'll just do that adding of repo. So if you know hem, you already know you need to add a repo first and then install. Wait a minute. Okay, so I have to go back because these commands are created with an assumption that you are working on an observability workshop folder, not the something inside that. So I will just wait a minute. Hem is not here. I can see hem on the control plane. I don't see hem on the node. So let me move to control plane and do a git clone from the control plane there. Or you can also install hem. I mean, maybe Sam, if you want to share that hem installation, if anybody want to doing it on node 0, node 0, 1 or 2, you can install hem, or you can work on the control plane, because I think control plane has hem. So I clone that. I will go to observability workshop. I will add my repo. So hem repo add OpenTelemetry official hem repo. I will just add that. This is added to my repo. I will just do hem repo update so that I get the latest charts. I'm not using any deprecated ones. It did update, and the next command is important one. Make sure you are using a value file, which is being mentioned. So I say hem install. I'm using hotel-demo as the name of the install. Make sure if you are using anything else in the future activities, you are going to use the same name. So you are not changing the name. So I'm using it as hotel-demo. It's on you what name you want to do. I'm going to deploy OpenTelemetry demo application through hem charts. I'm going to put into a namespace called hotel-demo namespace. Again, if you are putting into some different namespace, do make sure you are noting it down so that in future commands you will be using the same namespace. I said create namespace because if hotel demo does not exist, it's a new cluster. It will create that namespace, and this is the value file, hem hotel demo values.yml file. This is the value file of the hotel demo. I will not get into these value files because this is not our objective. Our objective is monitoring. This is just a prerequisite application. But if you are interested, you can go after this workshop, you can try to understand what this hotel demo application is and what all things it deploy. So yes, it's deployed. Take some time. Let me do the get port on my hotel demo namespace. Yes, a lot of containers are creating. It takes some time for all the container application to start running. If you see here, these are all the application microservices which runs. It has a lot of things. It has Go application, Python application, Java application, .NET application, OpenSearch, a lot of things. It do also have a LLM kind of a stuff also, the application, because recently the LLM of observability is also becoming popular. So that's a new feature which is getting added. So there are a lot of other things. You have PostgreSQL also. You have Valkey things. So there are a lot of component it has. Takes a minute or so for the application to come up. Wait. Okay, is this not okay? The ports. Yeah, it's coming up still. Okay. In the meantime, when this application is coming up, we'll try to deploy the Prometheus also. And let me go back and deploy my Prometheus server. So Prometheus server in the README file, right? If you go a little down, the lab 2, that is Prometheus server. So lab 1 has a lot more other commands also. We'll talk about that, why they are needed. But I will just go to lab 2, which says install Prometheus server thing. In that, there are 3 commands to add Prometheus servers, hemchart, and install. So you can run that. I'll just do that. Again, I'm adding Prometheus community. Now this is Prometheus on hemcharts, official hemcharts. I'm adding that repo and I will just install my Prometheus stuff. Again, lot of things, some things to be taken care of. Install whatever name you are giving to your hem release. Make sure you remember it because that will be used when we try to upgrade a lot of things. I'm using monitoring namespace here. Again, you can follow the same pattern or you can use your own namespace. Of course, create namespace and make sure you are using this value file. So if you don't provide this value file, still Prometheus will get installed, but some of your future activity might fail. I will talk about this, what this value nojob.yml contains in my second and third workshop. But as of now, this has kind of a no value file. It just configure couple of configuration parameter of Prometheus, nothing else. And I will talk about what those parameters are in the later stage. So I just install it. It will install into monitoring namespace. Let me see what is happening in my monitoring namespace. Okay, something are coming up there too. In the meantime, let me see if my application is up or not. Yes, everything is running, up and running in my application. And let me see if my Prometheus is also up or not. In the monitoring, yes, my Prometheus is also up. Now, one of the basic things, right, we generally do to monitor if Prometheus is not there. I wanted to put this Prometheus installation first because I want to talk something about that. In the meantime, everything comes up, right? Anything pending or everything start working. So one basic monitoring step most of the Kubernetes people do is the Kubernetes stop command, right? Most of the time. So let's try to run that and see what it actually do. Oh, some failure, right? So it means the metrics are not getting collected, right? Why? Because there is a separate installation of metric API which actually talk to kubelet and then expose those metrics to anything who want to consume it. In this case, the ktope command. In the later case, it will be Prometheus who will be doing that. So let's try to install metric API here. And metric API talk to kubelet, which is a Kubernetes native package, which actually expose or actually collect those information. Metric API is just exposing it to something, aggregating and exposing it to any tool which you want to do the monitoring. So if I go to the first lab again in my README file, we come up with first 2, 3, 4. The first 4 command we ran. the fifth command, which says metric server, add metric server and install the metric server. So I will install the metric servers now to make sure we have Kubernetes monitoring or the metric server up and running, which will expose those metrics, which will get captured by Top and Prometheus. So I'm just adding metric server repo. Again, it's coming from Kubernetes Hemcharts, official Kubernetes Hemcharts. I will just install my metric server, and this time I'm installing it Kube system repo. I generally put my metric server in Kube system because metric service is quite managed by the Kubernetes group itself. It's not something which is a third party. And generally, in many what you call, if you are using managed service, right, not the playground, you might see this metric server is already there, because many of the managed Kubernetes cluster do install it automatically as part of their managed service, so you don't need to install it separately. When you are using this playground, it's a raw vanilla Kubernetes cluster. It does not come with metric server out of the box. So I'm installing it. In most cases, in managed services, you will find it either in the Kube system or its own dedicated namespace called metric server. So in many of them, you will already be having it. So you don't need to do things. It got installed. Now, if you are using managed service, it's all good. You don't need to install. Everything is up and running, and you can start running ktop command to see these things. If you are using this playground, there's a little hack here because most of our nodes here is not having a TLS enabled in our playground. The little change we will do to the metric server config file, to the deployment actually, to say do not check TLS. Otherwise, it will start failing. So what I will do is I will edit my deployment metric server. So whatever I deployed, right? So in the Kube system, there is a deployment metric server which get deployed by the Hemchart. I will just edit it manually. And in the command of this, somewhere here, I'll just add another argument to the command to say --kubelet insecure -tls. Again, the README file has this. You can type it out or you can copy paste to avoid any typo mistake. --kubelet insecure -tls. So what this do is it actually tell metric server that my kubelet is actually insecure. It's not a TLS enabled. Again, it's a playground, so that's fine. So it does not have to do a TLS validation there. It can skip that to get the data. So I'll do this, and I'll just say get ports minus name Kube system. I will grep for metric and see if everything is up and running. Okay, the second one is still coming up because we edited it. So let's wait for a minute. It will come up. If you see the first one, right? First one was failing. Why? Because it was trying to do a TLS validation for kubelet node. It was not able to do it, so it was crashing. Because of that, it was not able to do. We make the edit. Now the second one runs fine. It's able to skip those validation and able to get the data. Let's try to run our command again. I will just say keep top nodes. And yes, I am able to see how much CPU usage each node has, how much memory usage each node has, and what is the memory percentage each node has. So this gives you a very basic information of what my usages are currently. Of course, you can build your own simple observability tool on top of it by running ktop nodes every 15-20 seconds or whatever you want to, putting into a text file and analyzing that text file. Use some tool to actually do a graph on the data on the text file. So that's a very basic observability thing which you can build without spending anything. The same things goes with knode ports. So ports are too much, so I will just look for hotel demo namespace where our application is running to see what is happening. So it gives me, for each port, it gives me what is my CPU and memory usages. So CPU is 2M, memory is 203 MI. So that's what it's all about. It does not give you percentage usage. It gives you an absolute number. But because kubelet only expose absolute number, to calculate the percentage, you have to run some script. So you have to figure it out what resource settings are for each port, what is my request and what is my limit set, take that value, take these value, the usage of it, and calculate the percentage use. You can always do that. I mean, that's something which you can do without any backend. Of course, backend support all these things out of the box, but you can do it without any backend. So if you go to our labs, right? So towards the end, there is a command in lab one, verify, test, and basic live monitoring. There is a change. Towards the end, last of that, there is a watch command, watch minus, and you can even do for search. This is actually a script which allow you to calculate percentage usage of your uh, 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 application ports. I will run it. I'm just giving you this example because just to say that you don't need a sophisticated backend every time. You can build something Kubernetes monitoring based upon this ktop command itself. I mean, it gives you, and you do some kind of a scripting to get percentage values, graphs, and everything without any sophisticated things. So this is what I'm just copying. It's a little complex shell script. It's doing watch. It's using watch SSH command. It's run every 2 seconds, and it will run this command. If you see this, I'm getting the ports from hotel demo namespace. I'm using JSON path and actually taking CPUs, memories, and everything information. I am also doing ktop command here. So I'm getting all the ports, querying it through JSON path to get their resources. I'm dividing that to what is being used currently by kubectl top command and finding the percentage multiplied by 100. Do give me, okay. So I see the CPU is there, memory is infinite. There's some problem with my script. I just created it in the last moment. So yeah, so 2%, 5%, 1%. So you calculate for each what you call node port, each port you are actually getting the percentage value now. So this gives you overall consumption or usage for you. So, and of course, I'm saying every 2 seconds, it's actually recalculating in every 2 seconds. Now you can post it to any text file or any Excel sheet and actually create the graph out of it. That's easily possible. So this is about ktop. So very basic monitoring, a lot of us do, and there are some more commands in that verification, verify, test, and basic live monitoring, that header. So that's do you can do the logs. I think everybody know how to see the logs. You can see kubectl logs, and you can provide the name of the deployment or the port. You can also see the events using kubectl get events. So you get all the events, what started, what created, what got pulled, all the events coming in here for all the latest one for each port. So yeah, these are the basic what you call commands you use. You use kubectl logs, kubectl events. You install metrics server, and you can get data from kubelet for CPU usage and memory usage. Now let's see what Prometheus is doing. Our Prometheus. Yep.
Interrupt you. So I think this is the end of lab one, right?
Yeah, this is the end of lab one. Yes.
Okay. So folks, so a lot of you are asking like, where are the commands and stuff? So this is the GitHub repository. It is pinned in the chat. And obviously for those who will be watching later, I'll be putting in the description of the video. So I'm also posting it again. So we also have a few playgrounds left, like 7 to 8 playgrounds. So if you do not have the playground created yet, it's pretty simple. You just go here. So this is the link. So I'm repeating everything just in 1 minute. So go to this link. This is a training. Then you join the training. When you join the training, you get the OTP link. When you get the OTP link, you will be able to put that and log in as a temporary user. When you log in as a temporary user, come back to this particular page, and then there is a playground link in the portal. When you go to the playground link and you start the playground, you will be able to see the playground opening with one control plane and 2 nodes. In the control plane, you have to clone the repository. You have to go inside, and then in the readme, you will be able to see these commands. Another option is you can just copy this and open it in a new tab. so that you can copy paste very easily. So right now what we have done is we have just created this the hotel demo Helm install of the OpenTelemetry in the namespace OpenTelemetry with the values file. That is why you need to clone the repository, because it has those values.yaml file. And then the metric server. And then when you create the metric server, obviously it fails because you need to add the argument kubelet insecure TLS. And then were the commands where Manoj was showing, like get pod, stop, top, logs, get events. And this was the script in the end that he ran to show the memory and the usage and stuff. So that's what it is. I hope it is clear now. Uh, but yeah, now we'll move to the lab two. That was the lab one.
Yeah. I'm sharing on my screen also. I hope the screen is visible.
Yes.
So this is the link which Sanyam was talking about. He has shared it in the chat. He has pinned it. There's a README file in that. What we did till now, we covered first session, second session, and then the lab one. And we have done some hands-on of the lab one by verifying some of those commands to see if we are able to see the monitoring data or not. So you can just run them one by one in the same order. It will work. I did a little different order. I did an OpenTelemetry first for command first. I skipped this metric server stuff. Then I went directly to install my Prometheus server. And then I came back again to install metric server and other stuff. But that is not the thing. This is just to explain. If you have not yet completed, you can just run this one by one, copy one by one, take just a few minutes to run it in the same order, and it will work without any problem. Just make sure when you do a git clone, after clone, you actually move your current working directory to an observability workshop folder, where the, because all other commands underneath it are actually assuming that your working directory is observability workshop folder. Based on that, all the paths and everything is actually being used. Yeah, so you can do the whole thing if you have not yet completed. Maybe take up just 2-3 minutes, run it in the same order. In the meantime, we will see. So from the installation perspective, everything is done. Even the lab 2, some part is done. But the more interesting part is exploring Prometheus now. You have deployed Prometheus, you have deployed metric server, you know CPU, memory usage, and everything is actually being shared by kubelet to the metric server. The next chapter is how Prometheus server now use this all setup to actually run scrap those data every few seconds and then keep it in its own time series database, where you can actually now run PromQL to get the historical data. So because it's saving, it's persisting all the outputs. Okay, let me go back here. So, and again, I just repeat, this playground will get expired if you don't run any command for 15-20 minutes. So make sure that you are actually doing it. Oh, something happened for me. Connection to stub closed by remote host. What happened? Why this is closed? Did I have? No, this is working. Okay, so my connection to the control plane has been closed due to some reason. I don't have hem on my nodes. So maybe let me try creating a new session to the control plane. Yes, it works. So some problem in my first session. Okay, so you can add more sessions by clicking on the plus sign, and you can create a new session. Due to some reason, the first one is failed. Hopefully this works. Yes, this works.
So sometimes it happens, like Manoj did. You can just click on that plus icon and create a new terminal session for that particular control plane.
Yeah. Okay, so let's now try to do some Prometheus hands-on. So in the lab 2, there is a section called Verify Prometheus UI and the job running by default. So we'll do the first one. First one is actually the port forward, because we want to see the UI of Prometheus now, what it's all about. We'll do the port forward. One trick here is to make sure when you're doing, either you copy paste from the README But if you are doing it from your local system, make sure that, I mean, if you're doing it from your playground, from this, make sure you adding this arg hyphen address 0.0.0.0. This is required for port forward to work fine. What I will be doing next is to actually do first port forward to this control plane, and then this control plane will do another proxy to my own local system to access the port forward, because I don't have the browser here. It's just a command line. So I did this. So its forward is successful. To make sure that I'm able to access now the 8081 port of this control plane, I just go here in this three dots and say expose HTTP port. This help you expose on your local system now. Because this was 8081, I put 8081 here from the control plane machine. If you're and I'll just expose. This gives me a link. Wait a minute. Okay? I need to zoom out a little because I have to see the link. It gives you a link down. You can. This is a temporary link created for you, and this links actually forward request to your control plane 8081 port. So I click on this. So I come to this page now. This is my Prometheus UI. So I'm able to open my Prometheus UI. So this is how a simpler backend look like. Prometheus we are now accessing a database of Prometheus through a UI. So it's exposing all the data it's capturing through those jobs. We'll look at the jobs also, what this Prometheus server is running after this. I just want to see this first. And it gives the UI. So if anybody is not able to do this UI, just let me know. Make sure you are using the right port forward command. Make sure you are actually using the right port here in this. So you are using the service Prometheus server, right service. 8081 80 port is the service port which is being doing. If you are doing port forward from a pod, not from service, port is 1990. So make sure you are using the right port. If you are doing a service port forwarding, then use the service port 80. If you are using the pod level of port forwarding, not the service level, then use 1990 instead of 80. So make sure that you are using the right port for port forwarding. So okay, so I'll just jump on to my Prometheus server. So my UI is visible, right? Prometheus UI, because I need to switch tabs. So I need to keep sharing different tabs. I hope my Prometheus, now you are able to see my Prometheus server UI. Sam, can you confirm you are able to see my Prometheus UI, right? Hello?
Oh, sorry, I was not on the stage. Yes, we can see. And
you gave me a shock. I thought I got disconnected from the StreamYard.
No, actually, I have to be on the stage for my audio to be heard.
Okay, that's fine. I'm just that's fine. So, okay, so on the thing. So let's first start is up. Up is a command which gives you what are the jobs which this Prometheus is running. If you recall our slide deck, jobs are nothing but the endpoints it's scrapping. So each endpoint this Prometheus is scrapping become a job, and these endpoints are application endpoints. In this case, these are the Metrics Server and Kubelet and API server, Kubernetes API server endpoints, which Prometheus is scrapping the data for. So I just say up here, just up. You don't have to do anything else. Just say up. That means it will show me all the jobs which are currently running. So these are the jobs which are currently running. Kubernetes API servers, Metrics CI, then this is the job, and then this is the job. Kubernetes Node CI advisor. So all these jobs there. So every up metric or up thing will have a job label which tell you which job this is running. So that give you up command. Now, if I say up and you put curly braces, and you can actually select a particular job. So I'm just
Manoj,
showing some of the PromQL how you can run.
sorry to cut. Manoj, can you show once more the port forward thing, because that is kind of the playground is new for folks. So if you can show how
Okay.
the port forward thing
Yeah.
works, where they need to click.
Okay. So from this your playground UI, right? There is on the right hand side topmost thing. Don't click on this power button. Just on the right side of your power button, there are three dots. Okay, wait a
I'm,
minute. I
I'm
will share my
only
tab.
saying,
Yeah,
okay,
yeah.
yeah.
I'm on this tab. Yeah. So on your playground, on the right hand side topmost, there are three dots. If you click on these three dots, there is something an option called expose HTTP port. So click on this port and mention which port you have used for port forwarding. In my case, I use 8081. If you use something else for your local control plane system, you can make use of that. Expose and you just mention 8081. Make sure the machine is control plane because that's from where we have done the port forward command. You use control plane and not the other ones. And just say expose. As soon as you click on expose, a link appears down there, a URL. That URL is a temporary URL which you can make use, which will forward all your requests to the control plane 8081 port. Click on that link and open it in the new tab, and you will actually see this. This thing will come up. Just make sure your port forward command is running. Sometime port forward command fails due to some reason, then the UI will not come up. So your port forward is actually running successfully. So that's something which you need to make sure. So this is my port forward command. Keep it here, running successfully. It's forwarding 8081 to 9090 on in the port, and it's connected. And this is my UI. Everything clear? Anybody has any doubt on that? Able to see the Prometheus UI? Okay. So the first command which I run is the up, which gives me the list of all the jobs which are running. Each up metric will have a job label which tell us which job this is actually, and we will see the configuration of these jobs when we look at our Prometheus config map later. I'm just wanted to play around here. You can do a curly brace, which is actually a filtering. So you see a key value or the label filtering. I just say job equals, and I say double quote, it gives me the list of updates. I just say C advisor and I execute. There are three C advisor jobs are running, one per node. So if you see instance, node 02, control plane 02, node 01. So one C advisor job is running on each node because this C advisor is actually doing a kubelet scrapping, and kubelet is one per node. So for each node, each kubelet, there is a one job which is running, and it's scrapping data from kubelet to get container memory, CPU usages, and everything every few seconds and storing into the Prometheus database. Let's see the metric now. I will just say type container. These are all the container metrics which are getting captured through kubelet. This is the kubelet which is exposing through C advisor, and Prometheus is actually scrapping C advisor to get this data. So let me see container, let me see memory or maybe CPU, whatever. I mean, you can play around with which one you want. I will say CPU user second total. So this is giving me the total usage of CPU. Uh, so if you see here, you will figure it out. There are many of them. Why? Because there are separate labels added to each. So each unique label combination create a new entry altogether. So if you see here, it's giving me the port level. So each port has its own CPU usage. You will be having a lot of ports, 15, 20 ports. Each one will have its own series for CPU usage. But what if I want to filter? Let me filter only for the ports for my hotel demo namespace. How I will do it? I'll put a curly brace and I will say namespace. So namespace is a label. I will say equal and I say hotel demo. This is my hotel demo namespace. Let me execute. It will reduce number of series to a little extent, but it's still giving me all the ports of hotel demo and their CPU usage currently. This is the value. You can see all the labels which are part of this and you can filter on any of them. What if I see, I just want to see the CPU usage of the pod under namespace hotel demo and the pod is running on node 02 instance. I mean node 02. I don't want anything which is running on node 01, but just because node 02. Because I have some issue with the node 02, there is CPU throttling or something. So I'll just put this comma and I'll just say instance equals. So there will be 3 of them. Because there are 3, I'll just say node 02. Now, what this is doing, it's giving me for all the ports which are running on node 02 in the namespace hotel demo. So it's giving me the CPU usage of those. It's for the drill down. So that's how you drill down based upon what you want to look at. Now, you want to do a function on top of it. So when you say second total, right, this actually gives you the total usage from the time Prometheus has actually started. It will keep on increasing. It's not going to do things. So if I click on graph down in the second, as of now I was seeing a table. I look at graph and you see the visualization of all the ports. If you see, they keep on increasing because it's a total usage. It's not an average usage. It's a total usage. And total usage will continue to grow until unless you restart your port. So restarting port means there will be new port coming in. The count will reset to 0 and it will start doing it again. So this is all the ports for all my ports, which is running in the hotel demo. What if I want to see the current usage, the average? I mean, what is current usage? These are not the total. Then there is a function called rate. The rate function do an average of usage. From this, calculate average increase. I mean, how much is increasing per second? So that is meant usage in that particular second. So I'll just use the rate. And rate works on a time. So you have to see from, I mean, rate should be calculated from last 5 minutes. So I'm saying just give me increase in the total usage from last 5 minutes. So I run this. I hope, because I'm building these statement live, not copy pasting it. So hopefully there is no syntax error. Yes, I got it correct. So now if you see, there is no continuous increase. This is giving me increase in the total every second from last 5 minutes. So that means what is the usage in the last 1 second? So it's giving me the usage in the last 1 second. It's pure mathematics. When you have a total, right? So you say the increase, the acceleration, the increase, the add-on every second, what is happening to the total. That's what I'm calculating through a rate function. So this gives me a kind of current usage. So that's how you actually do. Now, you can also alert on it. I'm not going to do that, but you can also create alerts. When I say for it, you build this PromQL and whatever you want to do, and then in the alert, use the same PromQL, but at the same time mention a threshold value. So for example, here it says 0.016, and I say, okay, if it goes beyond 0.020, then alert me. So you will just put this PromQL and put a threshold of 0.020. So for any of this port, if it goes beyond that, it will alert you. So you can actually create an alert. So Prometheus in itself is a very lightweight observability tool. But of course, it's not a production ready. But yeah, you can always use it in your demo and do it. So play around with some more. I mean, there are something called group by, there is average, a lot. I mean, Prometheus PromQL is very, very powerful. It can do a lot of functionality, mathematical calculations, percentage, usage, and then of course your what you call bucket creations and all that stuff. Do a lot of P99, P95, and all that stuff is also possible. So if I do this, I think there is a P99 or something. There are functions for each of those stuff which you can actually do. So you can play around about this, and that's the end of the second what you call our second workshop. Uh, Sam, if you want to give 5 minutes to the audience, if they want to play around with their for their Prometheus UI, do it. If there are any questions on that, we can always answer.
Yes, folks. So, if you have any questions, then you can please ask in the
And
chat.
maybe whoever is able to run this successfully, able to run, maybe you just a thumbs up or something so that we know people are able to do it successfully.
Yes, and you can give a thumbs up. And if you want to show any query or things, you can show that as well.
Yeah, if you're building your own query, you have built something which is not part of the README or doing yourself, maybe you can put that for everybody else. Others can take that query and try to run in their Prometheus thing.
Exactly. Sure, Guru. I can pull you up. Invite to the studio. Okay, I have sent the invite so that you can show. Meanwhile, I can also show things. Share screen. So if you see, like I did it once again because someone was saying I missed catching up, and I was not able to catch up. It's pretty easy. So you can still run these commands like I mentioned. Pretty easy on the port forward size, and I already have Prometheus running the queries and things. So what I'll do is I'll just pull in Guru. He's here, and I'll let him share some of the queries that he has quickly, and then we can resume with the workshop. Hey, hi, Guru. You can share the
Hi.
screen.
Okay. Yeah. Give me a minute. Share screen. Which one I want? The whole window because I have too many monitors. Just give me 1 minute. Okay. Let me know if you're able to see my screen, sir.
Yes. So,
Yes.
Daniel, if after you have Prometheus working, basically you will be opening a UI, and then you should be able to do some queries. That's what
Yeah.
we are doing. Some queries to
Correct.
understand what metrics are there, how you can query the metrics that we are actually scraping it.
Yeah. So for context for other people, I am not doing it on the playground which is provided by Sayam and Manoj. I am connected to my own Kubernetes cluster, which is on GCP, and I have a lot of applications. So the data which I am getting may be far more than the demo versions. So please don't get overwhelmed. Oh, गुरु के पास ज़्यादा आ रहा है, ऐसा कुछ नहीं है. ये मेरा कस्टम सर्वर है जिसमें बहुत सारे applications चल रहे हैं. So let me, for example, let's say I won't do it by node. I will say instance is equal to, or I'll just do a graph up, or let's say, for example, cube, because like cube cron job info. Let's say this is one of the tabs, right? So you can do a graph or something. And if you see, I have a lot more information, let's say up by pod is equal to like, for example, okay, it may be a bit complicated. Oh, you're able to see my thing. Oh, that's even better. So for people who do not understand the queries, so this is my up command which shows me everything. So let me copy and paste the commands from here so that I don't have to,
Just,
like, yeah.
just to let you know, we have 1 more minute before we give it back to Manoj.
Yeah, sure. So I'm copying the command so that I don't have to do it. So this is my data. Yeah, up by what is the command. So yeah, so this is some of the things which I'm able to see, and you should be able to group by pods as well. And that's all from me, sir.
Awesome. Thank you so much. So yeah, like this, what you can do is you will be able to, get some of the commands and see how things are working. Let me just
Yeah,
go
yeah.
back.
So some of the commands are already there in the README file. So yeah, maybe if you, I'm sure everybody is able to see the README, but maybe you can copy paste those commands in the chat also if somebody can pick
Yes,
up there and directly run in their Prometheus. Yes.
I can just show that quickly after copy pasting. So this is there, so you can see, and some by pod, so you can see. That's how it is. So Manoj has already put some commands in the chat section. So once again, you are not behind. Manoj is explaining things in detail. We have just, like, you just can still create the playground, do these, get the metric server up and
Yeah.
running, install the queues, expose it, and try it out. We have done till here. So um, over to you, Manoj.
Yeah. Thanks, Sam. Okay. So before I'll just share my screen again. I think I stopped it. Okay, so if you are playing with your Prometheus, make sure the port forward is continue to work. You can open a new session to do in parallel, or you can stop your port forward and continue here. I mean, it's all thing. So yeah, so we are ending seconds. I'll just jump on to slide deck again because we will just move now how this connects with OpenTelemetry. So we'll talk about a little bit of an OpenTelemetry now. And in the meantime, I mean, you can follow the whole stuff from the README file one by one in the same order, and everything works. I mean, they're the right order there. I might be running in a different order because I just wanted to explain, but you can actually run it in the same. Okay, so let's go to the slide deck again. We have completed the first two labs. We'll get to the third and fourth next. But before that, a 15 minutes of concept explanation, and then we'll move to the next. So yeah, we completed the first one. The second part we'll talk about is from monitoring to observability OpenTelemetry pipelines, right? Till now, what we were doing is metric or maybe sometime logs using the Kubernetes log command. But this is not is observability, right? Observability is a totally different concept from monitoring. Monitoring was I was checking, is my system healthy, by looking at some of those signals. But observability is not something just checking, is my system healthy. It has a lot more onto that, and I will see what different it has. And at the end of this session, we'll do another two workshops. We'll try to deploy a collector now. And then whatever you have done in Prometheus, I will go through Prometheus config because we have still skipped that. But the next workshop will go through what Prometheus configuration look like. You have already deployed a Prometheus server, but you haven't yet looked at the raw configuration. We'll look at the raw configuration of Prometheus and try to move one of the job from that config from Prometheus to OpenTelemetry. So exactly same job. I'm not doing anything fancy. I'm just saying moving Prometheus, a dedicated metric server running to an OpenTelemetry, one part of the OpenTelemetry to scrap metrics. So we'll do that. We'll migrate one of the job from Prometheus server to OpenTelemetry Collector, and uh, that's all about the third and fourth workshop. Let's talk about now observability. So is logs and infrastructure metrics enough for us, especially in containerized environments, especially in the kind of complex application we are writing, where hundreds of applications running. Each application again has tens or hundreds of replicas. So overall number of servers, I will not say physical server, but even a logical server running in containers are in thousands, even sometime even more, and they are interacting with each other. And every server is doing their own set of logging, own set of metrics, disconnected one completely. So become very challenging to actually figure it out the RCS. And that's where the third part of the story comes in, which is called traces, right? What log infrastructure is not doing, it doesn't give me any correlation. It doesn't give me, if this metric is high, for example, CPU of this container is high, can I jump on to exactly the logs created at that particular time? Can I do that? Quite no, not possible until unless there's something to correlate. If my user is not able to load its cart in its UI, what is the reason? Just looking at the log and infrastructure metric is just not possible. What we need is the whole path. When user click on the browser, say add to cart, something runs at the backend. What is that? I mean, how many API calls? What flow is running? We need to capture that. We just need not capture individual logs and metrics. We capture the whole flow, and this whole flow is not a concern of a single microservice. It's the concern across the architecture, across the flow, workflow of the request, which may go into hundreds of microservices, tens of databases, caches, WAF, lot of other component which is running, right? The request flow from all of them. So we want the whole flow. And that's where the trace come into picture. It gives you a lot better visibility. Okay, so I'll just go to the next. What is observability? I'm just trying to define. We define monitoring, which is like capturing signals to get the health of the system. Now we are defining observability. And I define observability contextualization of signals. So I'm not worried about a single signal. What I'm worried about, what is the story behind all the signals together? Trace, metrics, logs, what all the signals together is giving me, or giving me some what you call indication of what's wrong. So some examples are below. My response time of a call is a trace is high due to high CPU usage of the component service to which call is made. So this is this is combination of both. Response time of a call, that comes from trace. High CPU usage, that comes from metrics. And both are correlated. I'm saying observability gives me it's high because of the high CPU usage of component. So it gives me the correlation between my response time and the CPU usage. I'm getting a lot of out of memory in logs due to high GC or high usage of memory by a method. Again, lot of out of memory that is coming from log. That's the log entry. It's correlated with a metric, which is a GC. What is my GC going on at this time? That is associated with GC. That is further got associated. Why? Because there is a high usage of memory by a particular method that comes from profiling. So we correlate three things: logs, out of memory logs, with a metric of GC, and with a high usage of memory by a method profiling. So three different signals are giving me a single story. So that's what the observability all means. It doesn't work on an individual signals. It correlates signals and gives you the whole story, what is going behind that. And there are other two examples. I know this looks very fancy, but that's what the objective of observability is. When we talk about observability, it's not about only capturing signals. It's correlating signals and bring a story out of it. Okay, so what observability do? What is observability? We already talked about. How to get that observability is what we are going to talk now. So observability aggregate all data produced by IT system and correlate to find insights. That's what we were talking about, right? We are not talking about now individual signals, individual metric, individual log, or individual traces. We're seeing all data and then correlate them together. Provide visibility into the health of the system and impact of the one component on other. It's just not only the health. It's actually telling me who is impacting whom, which API is impacting, or which database is impacting how many APIs, which API is impacting how many users on the browser side. So it actually gives me that linkage. Required for distributed system, really needed because now we have a loosely coupled system. It's not a monolithic. We have hundreds of components which are loosely coupled together, and they can impact one another depending upon how the coupling is happening and how the code is being written, how reliable code is written. So you want to know the whole flow. Yep. So root cause especially it get easier because of this correlation, and because and it get easier to actually analyze a distributed system of a higher complexity. Okay, so signals, that's where I think the first question was profiles. And this is the slide which covers that. Metric log traces, everybody know we talk about metric log when we are talking about Prometheus. Trace, I have explained a little bit. It's a cross concern. It's not a single application concern. Across all the applications, how the workflow that the trace is. Profiles is not yet GA'd in OpenTelemetry, but that's another signal which is coming up. And this is actually giving you CPU or memory usage at a method level. I mean, you can easily say this particular method, how many CPU cycles this particular method has used, how many memory bytes this particular method has used. It actually gives you that. And it gives you a complete flame graph saying, okay, where the usage was high, where the usage was low over time. I mean, it gives you the graph. And this is very big thing. I mean, many people in the past, profiles is not something new. Profilers comes in even now, but most of the time these profilers are used in your dev test and in your stress environments where you are testing it out. Because a general saying is that profiles put a lot of load onto the application. It itself require a lot of memory and CPU to work, and it actually do a noisy neighbor stuff. But with OpenTelemetry, there are a lot of lightweight profilers are coming, which does not impact more than 2-3% of the overall your infrastructure cost or the resource usage, but gives you a real good visibility at a method level, even at a code line level. A single line of the code, how many CPU cycle it actually used, you can profile. And you can think of a lot of use cases now. I mean, how much help this profiler can give you. And on top of that, if these profilers can be enabled, disabled without recycling your application, that gives you even better visibility. That means whenever the issue came, right, you are saying out of memory or CPU throttling or something of that sort, you enable it immediately to check where the CPU usage are happening. And as soon as you find the root cause, you disable it. And if the impact of enabling, disabling is just 2-3-4% of the overall CPU memory usage, I'm sure this is a big win-win for everybody. But yeah, this is not GA and this is not yet available for all the languages. Java has it, I think Python has it. I'm not sure if other SDKs has it. You can always look at OpenTelemetry portal to see where are the support and at what level. I mean, beta, GA, or which level the support still exists. So yeah, that's about profiling. Events, I think everybody knows. Kubernetes event, everybody knows. But from an open collector perspective, events are treated as structured logs. So OpenTelemetry treat logs and structured logs separately. Mostly the application logs are just unstructured logs, which is coming and it converted into a JSON format. Events are more of a structured logs. It has a proper structure which can be queried individually. Logs are just a rigorous search. You just do some pattern searching, but an event you can actually do some query because it's a structured log. Structure is well defined. So that's the event part of it. And I hope this answer one of the questions which we had in our previous session. So talk about correlation. So this is important concept of Kubernetes and not the Kubernetes, the OpenTelemetry Collector. And Collector provides a lot of features to enable this correlation. You enrich your signals. When I talk about signals now, you will see I won't be talking metric traces and logs separately. I talk about signals, and all three are signals, even including profiles are signals. So when I talk about signals, I am talking about all the 3 or 4 pillars. So OpenTelemetry provide facilities to enrich your signals with common labels. So you can say this particular metric has a label called pod name. Similarly, this trace has a label called pod name. This logs has a pod name in its entry, in its message format. So pod name is common across all the 3 signals. When this is possible, you can correlate. You can easily say, show me the logs of a pod which actually has running this trace or span from the traces. So from the traces, you pick up a trace or an entry in the trace, the span, the individual call on a particular microservice. That individual call has a pod name in it. I'm saying pick that pod, go to the logs and give me the logs of that particular pod, and you get to know that, and you correlate. Very important thing which is I feel very powerful is I take a trace ID. a trace can be going through 10 or 20 microservices one by one. It started from the browser, it called your front end, it called your back end, it called your databases, and it might be calling your infrastructure, right? There are different calls. All the four calls is actually a single trace. Now I can say to my observability platform, give me the log of this trace ID. What it means? That means it actually gather logs from different microservices which are part of that trace, individual call from the end user, and I just consolidate log entries which are generated for that individual call, and this solves a lot of problem. I mean, I have a millions of lines of logs coming, and I just start filtering manually. Okay, for this particular user request, what are the entries? And it become very difficult because there are a lot of concurrent users which are actually calling. You might be having thousands of users which are logging in, and they are all producing the logs, right? And it's very difficult to see which log entry belongs to a particular user call. And this correlation solves that problem. And you have a trace ID in the logs, you have a trace ID in your traces. From the traces, you figure it out what are the path followed by the user call, and say, okay, give me the logs of this trace ID. And it actually go to each microservice, figure it out where the trace ID is in which log entries, pull in only those log entries and show you. So you have a single user call and the corresponding log entry with you, and that solves a lot of problems. And there are a lot of other correlation use cases which can be built onto, and that gives you a kind of a story creation. Okay, this trace has failed because there is a log entry, out of memory log entry here, and this is because there is a memory exhaustion or a higher GC in the metric being shown, and all are getting actually correlated through a code ID correlation key. I wanted everybody to understand, and I wanted to explain because correlation is the power which is actually powering the observability stories. Okay, so there are different type of collection. We already talked about pull based and push based. Traces are generally a push based model. Your code has a agent added to it, all the application code, and that agent is responsible for intercepting all the API calls, network calls, create a trace data out of it, and send it to your collector. So that's a push based model. So you have a agent or SDK running as part of the code. Then, of course, there is Prometheus based, a lot of metrics, which is an agent based. So it's pull. So there is a dedicated agent or a collector running, and it actually scrapping those endpoints, which is being generated by the application. Both the things are possible, and collector actually support both for any signal. And it's not only for tracing. It can even do a metric which is push based. You can have your own custom SDK created, add it to your application, and it actually follow the OTel semantics and OpenTelemetry API definitions, create those metrics and push it. So there is a standard libraries available for OpenTelemetry Collector. You can add and you can implement those methods, which allow you to actually push any signal to a collector. So you can build your own SDK based upon your own needs. And of course, there are standard SDKs available for various standard libraries. For example, connection pools. You have for Apache HTTP Tomcat server. There are standard SDKs which actually expose or give you the data for metrics, traces, and logs together. Okay, so this is about observability. Now we'll come on to an OpenTelemetry. And Sam, just let me know if there are any questions. I'll just stop here for a minute. I'll just
Yeah, there is one.
Yep.
Is that the collector or the OTel library embedded in the app gives this correlation capability?
Okay, so it's actually both. So I was talking about OTel SDK here. I mean, in the next slide, but okay, you already asked this question. OTel has different components.
People are not waiting for the next parts, which is a good thing as well.
Yeah. Okay. So I think this slide will answer. That's the next slide actually. So this slide will answer this question. So I will just hold on to that. Maybe we'll check on the other question before I start explaining this slide. Is there any other questions here? Oh.
Yeah, is OpenTelemetry same for Prometheus and ELK or Datadog?
See, OpenTelemetry is a standard. ELK, Datadog both support OpenTelemetry. And Prometheus is a totally different thing. I mean, Prometheus is a complementary. It's only for metric. OpenTelemetry is for all three: metric, signal, and tracing. It actually combines all the pillars together into a single component. Prometheus was only for metric, and OpenTelemetry do have Prometheus part of it as in it. It's not a full-fledged Prometheus, but for metric, it do support Prometheus-based scrapping. So it do have Prometheus, and we will be doing that workshop when we are migrating the Prometheus job into an OpenTelemetry Collector Prometheus receiver. The equivalent of Prometheus server is a Prometheus receiver in Collector. So we'll talk about that in that. But yeah, Datadog, ELK are the backends, and OpenTelemetry can be used for both. I mean, you can send OpenTelemetry generated data to Datadog as well as ELK. Oh, I mean, people are answering already, so that's fine. Okay, so let's get to the next slide then. So OpenTelemetry, what is OpenTelemetry actually? So it's not a single thing. There is a very different components available, and I will talk about each component one by one. First is an OTel API, that is a NoOps implementation. If you want to build your own instrumentation, I mean, not the standard instrumentation, you want to do your own instrumentation, it gives you an interface, right? I mean, if you are, I mean, I'm a old guy, so I know Java interfaces, right? So if you have built any Java implementation, there is a Java interface defined, which does not give you the implementation of method. It gives you only the definition of that method. Okay, what will be the argument, what will be the output, and what it should be supposed to do, and then you implement yourself. And I'm sure other languages has a similar concept. So OTel API gives you that interface. You can build your own collector. You can build your own SDK. Not the collector, the SDK. So SDK is separate from collector. So you want to build your own custom metrics, business level metrics, which are not part of the standard metrics collection, which OTel SDKs do. So you can just say the empty one and implement your. OTel SDK is an implementation of OTel APIs in a standard way. I mean, this is not a something use case wise. It's a standard SDKs implemented for various languages, but that does not mean you will use only standard. You can implement your own, or you can actually increment on the standard implementation. So you can take OTel SDK, you take the standard implementation, and you can start building on top of it few more metrics. Or you can just take an OTel API, no metrics, no standardization, build your own thing, and still remain an OpenTelemetry compliant. So that's what it is. OTel SDK is a interface. OTel SDK is an implementation. SDK is something which is generally added to your application. It's for push-based model, not the pull-based model. It's a push-based model where you add this SDK to your application and implement or use the standard ones. And this will actually generate trace, metrics, logs, all three things, and push to a component. And that component can be a Datadog or Elastic or a Grafana or whatever who would support directly, or an intermediary. That intermediary is an OpenTelemetry collector. Now, collector is act as an intermediary for OTel SDKs, something which is being pushed to that, and it can process that push data before it actually send it to the backend. So it can act as a value addition to an existing signal, receive it, do some processing, and then send it. But it has a dual responsibility. The second responsibility, it can also act as define own receivers. I mean, OTel SDK is one of that, which send it data, but it can add more receivers, especially the one which is pull-based, right? You can define the configuration of pull-based. Prometheus is one of that. You can define all your Prometheus jobs. So there are applications which are having SDK, they are pushing it, collector receive it, process it, send it to the backend. Collector can also define own receivers, especially the pull-based receivers or anything which is not an application-based, right? You want to pull something from the infrastructure, right? The infrastructure, you want to do it. And there are other what you call applications or middlewares which you are using, databases, caches, which actually expose their endpoints to actually fetch. You can actually use that too, to pull. So you can define on receivers, and you can also receive from SDKs which are already embedded in your application. Both of them, you do the processing and then you send it to the backend. And we will talk about that processing in a little bit time. You can take collector as a pipeline, an ETL job. If you are from a old generation, you understand, right? If you build a data warehousing and all, you build an ETL job. You extract it, you process it, and you load it. So you extract the data, which is either being sent to you or you are doing yourself through receivers. You process it, enrich it, do some processing, dropping, filtering, whatever you want to do, and then you actually send it to the backend. And this backend can be anything, any OpenTelemetry compliant backend, and most of the backend are OpenTelemetry compliant today, including the big 4, big 5, and the newbies which are coming in. Everybody is OpenTelemetry compliant. They receive OpenTelemetry data, so you can send it to anybody. They can process, they can visualize, they can create alerts and everything, and you can build your own also. From the open source, you can build LGTM, you can build NHB, all those things, right, which are open source available. You can build your own backend and send it across to them and process it. Okay, so yeah, so this is what we were talking about. Collector configuration. SDK is something which is already available out of the box. We will use out of the box. We will not do an instrumentation by ourselves. That is a little more advanced topic, maybe some other day, but we will take the standard ones and do that. Receivers are the one which are either the pull-based definitions, okay, from where to pull in, or just single definition to receive data from SDKs. So those are the receivers. They are actually the receivers or pullers of the data. Processors are the series of processing being done and exporter sending it to the backend. Connector I will not talk about today. This is a little more complex topic, maybe some other day. And then below is the pipeline, simple pipeline. If you see the processors are run in sequence. Receiver are in parallel. You can have 10 or 20, 30 receivers sending data to your collector pipeline. They can all receive data in parallel. But all the data which is being received go through the pipeline, in the processor pipeline in sequence. So the order matters, in which order you want to process. You want to processor 1, processor 2, processor n, right? It will go in sequence. And then the last processor can send it to the backend again in parallel. So if you have 4 backends, different backends, right? You are sending it to Elastic, Datadog, Dynatrace, New Relic, everybody. It can send all of them to this data in parallel. So it is not sequence. So that's a fan out, we call it. So that's how the overall pipeline works. This is just a bigger view of that. You receiver receives it from everybody, application infrastructure, Kubernetes, from where we are talking about Kubernetes today, on an application deployed on Kubernetes. But it can receive from any source, which actually either push or support pull model. Receiver, then processor, and then exporter, and to the backend. So that's how the whole pipeline works. So I will just skip because we already explained this in detail. Okay, OpenTelemetry Collector. When we talk about, I will talk about this configuration. The whole pipeline thing which you do here, right? Receiver, processor, exporter. You define in a config. You define your receivers, you define your processors, you define your exporters, and you build a pipeline definition on top of these definitions. So we'll talk about when we talk about the OpenTelemetry Collector building. We will be building trace pipeline, metrics pipeline, and the log pipeline in our next workshops. We'll skip that. We'll talk about this when we talk. We'll build the collector. So deployment patterns will not spend much time today. We'll be using the 4th one. So there are different ways you can build or deploy this pipeline. This pipeline can be deployed as a sidecar. It can be deployed as a deployment in Kubernetes, or this can be deployed as a demo set. There are a lot more complex architecture we will not talk about. Today, we will work on the demo set. So that's what our objective is. We will build the whole pipeline for trace, metrics, logs using a demo set deployment in our Kubernetes. And our demo set will act as a collector. And we will migrate only the metric part of the Prometheus to this demo set. Okay. So let's come to the hands-on lab 3 now. The first one is we will actually move our Prometheus config to OpenTelemetry Collector. And that's the first one we'll do. So we'll stop here and we'll move back to our playground. I hope my playground is not killed because it's more than 15 minutes. I didn't run anything. Hopefully it's not. Oh, it's not. It's still awake. Okay. Okay, so I'm coming back to my playground now, and I will stop here. If you haven't done your workshop 1, workshop 2, or if you have any questions, query of whatever we talked till now, you can ask your questions before we actually get on to the lab 3.
Yeah, I think there are questions like one of the ones that I can ask, but others mostly are being answered already in the chat. So one last one is like, what is the preferred deployment option in the production system?
Okay, so Sayam, I don't know if I refer people to our open source summit
Yeah, actually that
session.
can
I
be
mean,
a good one.
yeah, that's where. I mean, I don't know if the recordings are available or not, but one of the session which I gave with Sayam on Open and Saloni on Open Source Summit is to discuss these architectures, which architecture suit which use case, and we talk about those use cases and the architecture. Maybe you want to go through that little more complex, but don't want to talk about those complex use cases where your load balancers and the collector chaining and other things come into picture. But I will refer maybe when the OSS recordings are available, you can go through that 40 minutes recording. There is a demo also as part of that recording, which explains which architecture suits which use case. I don't know. I mean, Sayam, if you want to add, I don't want to get into the details of that because that will take up the whole workshop then.
Yeah, I have pasted the link of the recording in the chat.
Okay, great.
Yeah, I think we can carry on with the labs.
Okay, great. So the first we will deploy our collector as a demo set. Then I will look at my Prometheus job, which we created a Prometheus installation in our previous lab. Look at the configuration, pick one of the job, copy paste from Prometheus config to hotel config. This is just to showcase that exactly same thing works. I mean, collector is kind of a superset. Right? It include Prometheus jobs also. We'll migrate, we'll run it, and you will see when you run that collector, you have now two same set of jobs running at two levels. My Kubernetes, my Prometheus server is also running, my collector is also running. And on the Prometheus side, you will end up seeing double data. I mean, one is coming from my hotel collector, one is coming from Prometheus, and at that point in time, we will actually remove our Prometheus job because we don't want to duplicate. That's something like migrating from one solution, previous solution to a modern solution now. Okay. Again, you can go to that workshop, I mean the README file, lab 3, install basic hotel collector as demo set. It has just 3 commands. Again, similar stuff. You add the repo, the hem chart. You just add the hem chart of, okay, it's already there because we have added it when we deployed OpenTelemetry demo as our first workshop. So it's already there. That's good. And then I will just install my collector using one value file, which is there as part of our thing. So if you see here, I'm again installing, I'm keeping the name it as an hotel collector. I'm installing in a namespace called observability now. So my hotel demo application is an hotel demo namespace. My Prometheus is in my monitoring namespace, and my collector is now being running in my observability namespace. I say create namespace. I'm giving this file hem hotel collector values.yml. I will go to this value file now because I want to explain how the pipelines are defined because we have to migrate what is there in our Prometheus config to here. But first, let me do it's deployed. Let me see. So I always confuse between logs and ports. I always forget putting get in front of ports, and I always put get when I'm trying to get logs. So I'm always confused. Okay, so ability. So let me do that. Okay, so my collector is quite fast. So all the 3, because it's a demo set, it will run one replica on each node. We have 3 nodes: control plane, node 0, node 2, and it will actually get executed on all 3. So now I will get onto a value file and then to the config map. Okay, let me look at the config map because value file is nothing but is getting a config map get created from those values. So that's the similar stuff. Let me see, get config map from my observability namespace. So this is the config map which got created from the hem chart when we do hem deploy. Let me try edit this config map to see what it actually is. Oops, sorry, I forgot to do the copy. Let's do this. I think font is good enough, Sayam. Do you want me to increase the font? Maybe I will do a little bit more clearer. I'm just editing this.
I think it's good enough.
Okay, so I did the observability. Okay, so this is my config map for my collector. Now, let's see what it has actually. So if you think about what we discussed, right? Receivers, exporters, processors, and pipelines. So this has just the definition of those. So line this, 8 line, it is actually defining my exporters. As of now, only debug exporters. Exporters are something which send data to your backend. That backend can be anything. I haven't defined anything yet. We will define as we move further in the workshop. I have defined processors, very basic batch and memory limiter. Batch is nothing but I don't just want to avoid making call to my backend every time I receive data. I want to batch it in some memory size and then send it in a single call. That's what. Memory limiter is actually trying to limit the memory usage of my collector processor. It actually do some kind of a back pressure when memory reaches a threshold to avoid out of memory. So this is more on the reliability side. I'll skip that. Then there are receivers. That is the data who is receiving that data. It includes both pull and push based. Jaeger, that is actually receiving it from Jaeger. That means it's actually a push based stuff. OTLP, again a push based stuff. If you see, I am not defining anything. I'm just saying the endpoints. What this do? When you say push based, that means the SDK is sending the data, right? Sending the data to what? Sending the data to an endpoint, which we configured in our application. But okay, send the data to this endpoint. And that endpoint is nothing but the collector endpoint. It's sending the data to the collector. Now, in my definition, I'm saying somebody is going to send data to this, to you, receive it. So I'm saying you either will see the data on gRPC or you will see the data on HTTP. These are the endpoints. So it says, okay, on this endpoint, you are going to get a data on it. So make sure you're listening to these endpoints and you're actually receiving the data. That's what I'm defining here. Prometheus, that is pull-based. So this is not a full-fledged Prometheus server. This is just a Prometheus core, which comes as part of the OpenTelemetry Collector. And this actually to support Prometheus jobs. Exactly what you define your Prometheus server, I will talk about that. Exactly same thing you're defining here. Here, if you will see, I'm defining the targets. What I'm saying is, these are the scrap endpoints. Now, this receiver will not just listen. It will actually start creating a job which will actually call these endpoints every 10 seconds and get the data and then do the next step. So this is saying, don't just listen, but go to this target, make the call to that target, get the data and put it to the backend. While here, which was is actually a push-based thing, which is saying, okay, just listen. Somebody is going to send you the data. Just receive that and process it. That's what it supports both things. And accordingly, configuration differs. So when you say pull-based, the endpoint means you will receive data, listen to it. While in that, in your Prometheus thing, you're saying go and pull data from this endpoint. So that's the difference. So yeah, so once you define, this is not you're creating it. This is just a definition, just like a definition of function. When you write a code, right, your definition write functions, but they are not immediately called. Somebody has to call it, and who will call it? The pipeline. So I then define pipelines, and in that pipeline, for all the three logs, metrics, and traces, I define the pipeline. I will see okay what the ETL will look like. If you say pipeline, it will say receive it from OTLP, process through memory limiter and batch, and export it to the debug. When I say debug exporter, that means only into the console as a log entry. It's just sending it to the log entry, it's not sending it to the backend. All the data is actually just dumped onto the console. That's what it means. So in the processor, it will first do the memory limiter, then the batch, because this is sequence, not in parallel. Receiver is OTLP. You can add as many exporter, add many receiver into that. As per pipeline, if you put receiver, 4 receivers here, all the 4 will have a concurrent receiver. So everybody will start getting data in parallel. But all the data which multiple receivers are getting, they will be put in sequence to these processors and then exported parallelly to the multiple backends. That's how it happens. Similarly, there is a metric pipeline, there is a trace pipeline. So if you have defined any receiver and exporter here, but you are not using in your pipeline, it has no use. You are defining a function, but you are not making call to that function. It's no use. It's a dead code. Similarly, if you are defining your receiver, exporter, processor, but you are not using it in your pipeline, these are a dead receiver. They have no value. So you have to make use it here. Define the pipeline. So this is how the whole config of OpenTelemetry look like. It's a very basic config which we have added. We will build on top of this config later. Let's now look at config of Prometheus, which we deployed previously, right? So I just say get CM. I will just say from monitoring. If I remember correctly, I did it in monitoring namespace. Hopefully, yes. Yes. So there is something called Prometheus server config. So let me see what it has. Okay. If you see, this has only definition of jobs. So this works only with one signal metric. So it does not have to define individual pipelines and all. It just gives you the definition of jobs. So these are all the jobs. There are 10, 12 jobs, which is defining one of the job we will migrate. I will just explain one of the job. It is what it is. So you say scrap config and you define job. Job name define how this will be shown on the backend. You can search on that. So it is a Kubernetes config. So Prometheus gives you configuration for various components, middlewares, which actually expose Prometheus endpoints. So you have Kubernetes as the config. You will have a lot of other discovery configs, as the service discovery. So service discovery config. So what it do, role, it says, go to my Kubernetes cluster, use this token to log into my Kubernetes cluster, bearer token, figure it out all the endpoint slices. Endpoint slice is an object, all the endpoints. From that, get all the endpoint, discover all the endpoints. In that endpoint, filter it out from namespace, service name, and port name. So my namespace should match default, pulling in from the default. My service name match Kubernetes. My port name match HTTPS. So how this works, whatever the source label you mentioned, they are actually concatenated with colon, and then they are matched with this regex. So I'm saying put all the endpoint slices which are in the default namespace, have a service name called Kubernetes, and having a port, the name HTTPS. So discover those. It's actually discovering that. Discovered everything. And now go ahead and start scrapping those discovered endpoints at this HTTPS port. That's all. By default, it's assumed that this endpoints will have /metric as the endpoint where it's exposing the metrics. So that's use it. If you go to the next job, it has a little more explicit about your what you call metric path. In this, I'm saying now role is node. That means again Kubernetes as the config. I'm saying go and discover all the nodes. But on this node, don't use the default metric path, because now the metric path is /metric/CA advisor. Otherwise, default was /metric. If you don't provide anything, it will assume /metrics is the default path. So on all the nodes of their IPs, /metric/CA advisor, go there and actually start scrapping. That's what it says. Again, it says certificates, and of course, you have to provide a token or authentication, because it cannot log into the API server without that. So I'm saying use this token and use this CA certificate for logging into your API endpoints. Same others. I mean, there are other jobs, lot of other jobs. which actually being defined. So this is how you actually start defining in the configuration. And Prometheus will do the discovery based upon what roles, what conditions you have mentioned, what metric path you have mentioned, and then discover those endpoints, create those targets, create those processes, get that what you call interval, which you have defined at the start as a global. So 10-second interval you are doing. Sorry, 1 minute is interval and timeout is 10 seconds. That means if there is the API endpoint, the metric path, which is scrapping, is not giving you response in 10 seconds, just do the timeout. You don't need to continue to wait. That is. Now we will actually move this job to our collector as it is without change. So what we will do now, I mean, two ways. I mean, if somebody is feeling quite excited, you can copy your value files to your home directory and start editing it. If you are not feeling so lucky, you can go to the what you call your Git repo and take up the file which called -Prometheus and do the diff between the default value file and the Kubernetes to see what things got added. So if you see what we deployed here, we deployed with this value.yml file. We already look at this value.yml file. This is exactly same what the CM is, but I will go and open this file also. So the config map which we look for collector, right, which is coming from this value file. Oops, I think I have a habit of doing right click and assuming it's copied. That's how most command line works, not here. I will just need to do a right click and do a copy. I'll just do a paste here. You will see something similar. I mean, the same exporter service, everything goes to CM. Whatever you're defining here, a config map get created. So we are already seeing all this stuff. But what you now edit? So we will already have a Prometheus receiver. Where is my Prometheus receiver? Is config receiver OTLP processor. Oh, there's no Prometheus receiver here. We had it in config map. Okay, that's the default what I did. So what you will do here in the value, you will add a Prometheus receiver here. So go to the value file if you are editing. I'm editing the value file now. If you are not editing the value file, you can actually do the diff. Just directly pick something from here. I will just show you there. Share this tab. So I hope my repo is visible. You just go to hem, hotel collector. This is the value file which we used, which is the default one, which I'm editing currently. This is the value file where we want to reach. You can always do the diff and see what are the things getting added. What I'm trying to do is I'm just trying to edit this file and manually add those changes so that we understand what is the diff here, right? Easily. Based on your luck, you can try out. And end of the day, if you are failed to do so, you can directly deploy using this file instead of the new modified file from values. Depend on you. So what I'm explaining, what I'm going to do. So I have a receiver defined here, right? And there is one receiver only OTLP. What I'm going to do, I just define another receiver here, just below OTLP. Of course, I need to make sure my syntax is correct. So I'll just say Prometheus. I hope this is correct. Yes. So I'm defining Prometheus, which is my new receiver down below. Okay, sorry, I think I didn't share. I'm sharing now. Sorry. Okay, so I'm just defined. Okay, I'll just delete what I did currently. So this is my default one. So what I'm doing is I'm just creating a new receiver under second receiver. So receiver is my definition. I'm just creating a second receiver under OTLP. I'm just saying Prometheus. I hope I don't do any syntax mistake. I hope this is exactly under. No, there's one more space. Okay. So I just need to see this. Okay, and I'm now defining my Prometheus receiver. So you can define any number of receivers in the hotel collector. Now, what this my Prometheus receiver, the definition will be, I will say config, and under that I say scrap config. I hope I don't do any syntax mistake here. So from here, so these two are OpenTelemetry Collector specific. After that, the whole scrap config can be copied from my from my Prometheus config. So I'm going to copy that. Exact the job I copying from config map. From what? So let me create a new session for control plane, and I'll show you what I'm copying. So I'm copying from this. Is the type head works here? No, it doesn't. It's not working. Let me copy from here. So I'm copying one of the job of the scrap config. So if you see this one, this, exactly this. Oh, wait a minute. Page up, page up, page up. Where is my config? Here it is. So this part up to this line here till the time the next job starts. I'm just copying exactly this thing to my here scrap config, under scrap config. Of course, you need to make sure that syntactically correct, nothing mistake I am doing. It's to start here. If you are copy pasting having some problem, make sure under the scrap config, the next element starts from job name and rest of the things is aligned as it is. This is an array of things, job names. Okay. Bearer token file, is it aligned? I don't think so. I have to move a little here. Kubernetes SD config, go down. Metric path is this. Role is node. And then I say read. So I have to do 2 spaces added on each line to get it right. So I added 2 lines to make it correct. Looks correct now, hopefully. So you did, what you did is Prometheus receiver added. So I have defined my Prometheus receiver exactly in the same way as my Prometheus server did. Now I will define an exporter. So when we did a Prometheus server installation through Hemwrite, we haven't defined exporter because by default it sent it to the Prometheus server. But from an OpenTelemetry collector perspective, backend can be anything. It may be a Prometheus server, it may be Grafana, it may be Datadog, New Relic, anything. So you have to define where this metric should be sent. So what I will do is I will define another exporter. As of now, exporter is only debug. So now I will define a new exporter, which is new in the OpenTelemetry, which is called Prometheus Remote Write. So this is an exporter which write Prometheus data to any backend. Okay. So I just say Prometheus Remote Write. It require a endpoint. This endpoint is nothing but my Prometheus server endpoint. So where you deploy it, right? So I just use that. I kept it handy, but it's very simple. HTTPS Prometheus server is the name of the service. Monitoring is my namespace .svc.cluster.local. So everybody understands the DNS naming convention of a Prometheus, right? So I'm running my Prometheus server in my monitoring namespace, and I'm just adding /API/v1/write. That is the write endpoint of Prometheus, where the Prometheus Remote Write writes. So use the same and use /API/v1/write. That's the endpoint you do. And of course, you can see in the /Prometheus value file, this is all defined. You can copy paste from there in your value file if you want. An add-on is resource to telemetry conversion. So Prometheus and OpenTelemetry has a different concept actually from the label perspective. So Prometheus generally call it, OpenTelemetry generally call it as attributes. Prometheus call it labels. And I need to explicitly mention that I want to convert all the labels of Prometheus when you scrap into my resource attributes on the OpenTelemetry side. OpenTelemetry side has a concept of resource plus the metric or the signal data. Resource, who is generating it. Signal is what data it is exactly. Prometheus has no such concept. It only know what is generating. It only capture data. Who is generating? No, not sure. I don't know what is the which application is actually generating it. I know only the targets and I just scrap. That's the Prometheus. But when it comes to an OpenTelemetry collector, it actually keep track of both who is generating it and what it's generating. The resource is who and the data is what. So I just say, okay, convert all the Prometheus label. I assume that all the labels are actually the metadata of resource, and I just see convert that to resource converter. So that's all. What is missing now? I defined receiver, I defined exporter. I need to add it to my pipeline now, metric pipeline. So I'll just go to my metric pipeline. Receiver is only OTLP. We added another receiver now. I will add Prometheus here because I added another receiver. In the exporter, I added another exporter, which is Prometheus Remote Write. I will just do that Prometheus Remote Write here. That's all. Anything missing? I hope nothing. I have done everything. I have spelling and everything is correct, hopefully. I just hoping that I did the stuff and syntax things correct. Nothing is wrong. Let me save and try if this works. I did the value file change. What I did, I added Prometheus receiver, I added Prometheus remote write exporter, I updated my pipelines to receive data from Prometheus and export it to the Prometheus remote write, that is the observability pipeline. Now, before I do, I want to show you how many jobs are running currently in Prometheus, and we'll see if there's a duplicate data start coming as soon as we deploy. So I will just go and do a port forward. Okay, I'll just skip this. In this, we actually did a port forward for Prometheus, which I killed it. I'll just do it again. Okay, this one is running. I will just say refresh here, which we are doing earlier. Okay, let me share this tab. Okay, so I'll just go and see up. I'm saying jobs. Prometheus is running these jobs. What is the job? We are moving this Kubernetes not CI. This is what we are moving from Prometheus to OpenTelemetry Collector. I execute this. I will just go to the table and see. Okay, there are 3 jobs, 1 on each. That's the current status. Let me go and deploy again and see what happens. So what I do, I just now, whatever I installed, right, OpenTelemetry Collector, I will use the same value file. Whoever made changes to the value file can use value file. Whoever is not want to make use of the ready-made ones, they can actually make this. Oh, okay, you just make this to value - Prometheus. I think that's the name of the file. If I am right, let me check that. The file name is value - prometheus.yml. I mean, you can update that so that you can use the ready-made file, which is already edited one. If you have changed value.file, you can make use of that. Let's see if my edit works. Hopefully, I'm lucky enough.
You can change your screen.
Okay. Okay. Yep. Yeah. So I will just repeat what I said. Hem upgrade. I'm just using the same hem command. I just say instead of install, I'm now upgrading it, and I am using the updated value files here. I mean, if you are not editing it, want to use the ready-made one, just make this change to value - prometheus.yml. That's the file which is already exists in that folder and which is already having all the diffs. If you have made changes in the value, just make use of the updated file. You can do the diff also to make the comparison. I did it. I hope my ports are not crashing because I have done some syntax mistake. Let me check. So this was in my observability. Wait, I again forgot to say port. Port and logs are always confusing. Okay. Oh, everything is running 60 seconds. So I'm lucky enough to make two good changes. Now let's go to the Prometheus again and see what is happening. We are collecting the same data, same job running twice, one through Prometheus server, other through collectors. So I will do the port forward again, which I was doing earlier. My port forward command. There it is. And let me go and refresh and see what happens. Okay, share this tab. I still see 3. Why? Okay, I know the reason now. Let me go. Let me see the logs. Let me maybe create another session. Let's not kill the port forward. Okay. Now let me see the logs. Oh, okay. Everything is running fine, but does my logs say everything is fine? Let me see. There are a lot of errors. If you see this, if you see, these are all RBAC errors. That means the collector which I'm running, the service account which I'm using is actually not having access to get all the data, which is now trying to scrap. My Prometheus had it again because Prometheus come up with everything out of the box. It has actually created a cluster role for itself by the hem. But the hem which we are using now to deploy OpenTelemetry Collector does not have that cluster roles created. So if you see this, okay, so I'm just saying get cluster rows from, okay. So, oh, there's a long one. I may have to see grep prom. So there is a Prometheus server cluster role, which Prometheus created through his Helm chart. And the service account is using this. But let me see if something of that sort get created for OTel. There's nothing. I mean, there's no cluster role. So our service account is a default service account, does not have anything, any access to make calls to API. So what I will do now, I will edit my value file again. So I will just go to observability and I will say bi hem slash hotel collector values.yml file. This is the file which I was editing, and I will add specifically in my Helm chart saying you have to create a cluster role and assign. That is another very basic, I will not say basic, but a problem. Many a times you don't see data when you are using an OTel collector because collector does not have access to scrap or get or make API calls of the cluster to get those data. So I will just add a cluster role here. You can take that cluster role definition toward the end of that file at the root level. You add the cluster role. You can take it from the value Prometheus file. It has that cluster role. Just look for a cluster role and pull the whole definition of cluster role. So that, like saying, create this cluster role and assign it to the service account of which is used to run the code. I'm just copy pasting. You can also copy paste. I can't type so much, so I just copy pasting. I just here cluster row. It's creating a row, and it's actually saying do the get list watch of all the resources because that's what it actually do. It need to watch everything to get the data, and of course it has to scrap /metrics URL. It is saying okay, you allow to do a get on these metrics for all the endpoints. So that's from where the data will come. That's how our job says, endpoint slicing. That's what we are discovering on. So I did this and I will just upgrade again. Where is my upgrade command? Oh, this is on the other side. Maybe I will switch back to my control plane 01. Okay, because I don't want to type my upgrade command again. So I'm upgrading because I've added cluster role. I will end up getting a new cluster role now. And because this is only new cluster role creation, there is no pod configuration change happen. Pod will not restart, right? That's the basic concept. Pods minus name observability. So pod is working fine, that's fine, but our my cluster all got created. Let's go back and see now if the data is coming or not, if what jobs are saying. So I'm doing a port forward again. I'm going to my Prometheus tab. I'm just doing a refresh. It's just a few seconds. Hopefully the things will start coming. It takes some time. No, there's nothing yet. Okay, now it's good. So the first 3 jobs are coming from my Prometheus server. Next 3 jobs are coming from my hotel collector. Exactly same data getting captured with an additional labels, additional metadata coming in, which is not the part here, right? So we have a few more additional data added here. So that's perfectly fine. We are getting more data here. So these are the 6. But do we really need duplicates? All right, I don't need a duplicate data. So I just want to remove the Prometheus one now because I'm migrating. I have tested it out. Data is coming correct, exactly the same. I don't want the duplicate. I want to remove. So I just see a brute force way of doing it. I will just edit the config map of Prometheus, remove that job from that config map, and then get CM minus name monitoring where my Prometheus config map is in, and just edit this Prometheus server config map and delete it. Delete that job which I have added already to my Prometheus, to my OpenTelemetry Collector. Okay, let me edit. What happened? Oh, I forgot to say CM. Oh my god. Okay, so let me go. Which one I added? I added, I think, which job? I think I did this one, not the advisor, right? This. So I will delete from this line till the next job. Just go here. So I just delete this. Up to this. I hope I've not deleted any extra line. Do this, config map is saved, and I just restart my Prometheus server because change in config map will not result into restart. So I just say okay, delete pod. Where is my Prometheus server? This one? Yes. I just delete this one only.
You have not switched the
Okay. Sorry guys. So what I'm doing, I'm just removed. Okay, I'll go again. What I did, I edited Prometheus server configuration, and I went to that job which I copied and I removed it completely from here. So it was part of here, somewhere here. This is no more exists. So that was C advisor, not C advisor, which is no more here now. I just removed that. I saved this config, and now I'm just deleting the Prometheus server code so that the configuration is in effect. What happened? Monitoring YK delete pod. I'm just pod Prometheus delete. Okay, so this is now restarted. That means in some time you will again see here. Let's again this. There were 6 jobs. I deleted now the jobs from the Prometheus server. Hopefully in some time the first 3 jobs will go away. So the jobs which are now up is actually the 3. What happened? something happens. The jobs which you will see only these three, which is coming from the collector. So the three from the Prometheus is gone. So this I'm just showing only you the up metrics. But if you start querying container memory usage and all the stuff which we ran, right, you will see the number of metrics are doubled because they are duplicate. Each metric is duplicate. One coming from hotel collector, one coming from Prometheus. What we did, we removed the Prometheus job so that we stopped collecting from Prometheus because we are collecting from the hotel collector now. So only the 3.1 comes. You can run the same uh, command, same PromQLs now, which you ran for Prometheus, and you will get the exact same data. But this time, the data is coming from collector, not from the Prometheus server. Okay, so this ends our third and fourth lab here. So we are left with the two more, maybe another 45 minutes of time we will take there. But I will stop here and over to you, Sam. I mean, if you want to take some break now, or you want to continue, or any questions, or maybe I can take up any questions if there is any.
Yeah, I think folks are doing. Folks, if you have any questions, meanwhile, or if you want to ask anything, what configurations Manoj changed, or which config maps he changed, so he can actually tell that, or if any other questions that you have, please let us know in the chat. Guru has been helpful in the chat. He has been answering a lot of questions already that I can see. Yeah, we can take like maybe 5-10 minutes break, Manoj, so that people can go refresh and come back.
No, so just I think Chetan has question, right? Manoj did not assign that cluster role to SA. So I put that cluster role to a hem chart, and my hem chart, if you say there's something called create role binding, true. I did that flag. So that means, and that flag is actually true by default also. So my hem chart makes sure that cluster role which I'm creating is assigned to my uh, service account, and you can actually query your cluster role binding, and you will see that role binding has already happened. So that's my hem chart take care of. To my hem chart, I just need to give the definition of cluster role binding. It automatically take care of. So that the template already exists in the hem. Okay, so Sam, we want to take a break for maybe 5-10 minutes, 10 minutes or so.
Yeah, I'm fine. We can take a break and we can come back in 5-10 minutes and then we can continue.
Okay, and in the meantime, I mean, you can follow that README. If you're still not done, you can follow the steps as it is, and things will work. If you want to clean up things, you can clean up and retry again, in case you're stuck somewhere.
Yep, and these new files are also there in the Git or not? The new edited.
If there. So I now recently in the last lab, I changed value to value -prometheus.yml. Both these files are part of the Git repo in hotel collector folder.
So people can directly use the new files.
Yes. So first deployment they did value -prometheus.yml. This is hem-hotel collector -path.
Values -prometheus.yml. Okay, and the other one
is value. We started with values.yml. We reached to value -prometheus.yml.
Okay, so if you want to get the edited file, all the changes that Manoj did, you can just upgrade the Helm deployment and use the values -prometheus.yml.
Yes.
I mean, if you want to come to the same page where Manoj is right now.
Yes. So if by any chance value.yml edited is not working because of some issue, you just upgrade through value -prometheus.yml. Don't use your value YML, and you will reach to the same level. And going forward, in the next, you use value -prometheus.yml to edit that file for the next step.
Yep, and the same command I think is also mentioned on your README, right?
Yes, README directly use value -prometheus.yml.
Yeah, and Manoj was just explaining what happened throughout from values to values -prometheus.yml. But yeah, if someone is starting out, you can just do the Helm install and then use that values -prometheus.yml file, and then you should be on kindly on the same page as he is right now.
Yeah.
Yeah.
Okay. So we'll just, I think it's 12:45 now, maybe 12:55. We join again.
Yes, so it's 12:45 p.m. IST, and we will resume it at 12:55 IST. Let me
Okay.
see if there are any timers and things. Yeah, Manoj, you can take the break now.
Sure. Thank you.
Let me see. In the meanwhile, do we have any timer? Time. Please take it down. There should be some time. Or maybe a background music. All right. So we'll be back in 10 minutes.
And guys, make
We,
sure your session remains alive. I mean,
yep,
if you have done something, so just in between 5 minutes or 7 minutes, just come and run kubectl command something, so that it remains
yep.
alive here.
Meanwhile, I can show you some stuff what I have been working on. So, uh, you know, so these days I have been working a lot on the AI infrastructure side of things. And this is the 7 days of VGX Spark. Basically, this is the 7 days of local LLM. Each log is like very heavy read, 26 minutes, 19 minutes, 28 minutes. They are big reads, and I'll post the link in the chat as well so that you can go and read them. So this is basically for any DevOps engineer that can be an SRE, anyone, uh, on how things are getting started, what is, what happens in the prompt when you ask LLM questions, when you go more deep dive into when you do a prompt, like when you write a prompt to chat, what all stages go through, and oh, okay, sorry about that. I forgot that the music was running. My bad. So, what I was saying is that the second one covers the anatomy of a LLM inference request, like from the prompt till the decode. Like you have prompt, then prefill, then KV cache, then decode. How each of the steps work, and with example, like for example, what is the capital of France? Model returns Paris, but what happens behind the scenes of when these things happen, like how it breaks down into tokens, what is prefill, then how the KV cache builds up, then what is decode, how the cache keeps growing in, and some animations as well in between, some good diagrams on what happens and how it streams the answer one by one. So it has a very good read. And the third one is obviously of the DGX Spark, and the fourth one is quantization. The fifth one that I'm writing, which is almost complete, is on inference engines, like what all engines are there and how you can use them, and then all the other things. So yeah, I think this is something which is there. Then yeah, this was what I was talking about. um, the daily newsletter that I'm writing. So like for example, Hammy is a CNCF incubating project, the cloud native infra things, worth reading some of the cool stuff that I am reading, some of the events, like for example, this event was also mentioned here. We are also doing a meetup in Chandigarh. We'll soon be doing a India series on local LLM. I'm looking out for sponsors. So if you have any connects, you can have me connected to them and then my take. So I think these are the ways where you can get connected and you can try and see what is happening. And then if you want to completely begin, there is also this book. If you go to directly kubesimplify.com, there is GPU enabled platforms on Kubernetes book that you can download for free. And yes, I will be covering VLLM and Slang and some of the other things as well. So staying connected is my Discord. So this is the okay, Discord. Also you can just scroll down and you can see over here this little icon beyond, just beside the YouTube one. which is Discord. So you can join us on Discord. That is something which is there. And yeah, I think, yeah, these are the helps that we need, like subscribing to our channel, sharing what we create, subscribing to the newsletter to stay updated, and then the blogs. So all the blogs that we are writing. So we are actually writing very cool blogs. So recent blog was by Shubham, who actually created the course on operators in depth. So if you don't know, we do have a operator course, very big operator course. You can see it's a 6 hour 19-minute course. It dwells into deep dive, and actually we went ahead and we created in production. We have a DGX Spark playlist which no one has. So you can see after that also, like how to handle multiple controllers, operators best practices, make your operators handle 10x more users. So it's the only comprehensive series, be it paid or free. No one has ever covered operators in this depth, and this is absolutely free, obviously. So he wrote a blog on Agent Gateway. So Agent Gateway is also one of the projects. So if you see this Agent Gateway, so that's the project. It's in the Agentic AI Foundation, AAIF. I'm also AAIF ambassador. So he created a complete blog on running AI agents behind the Agent Gateway and route their LLM and MCP tool calls through one proxy. And this is just the part one. How you can get all these things, how you can run on your local. You have Google ADK. This is the kind cluster, and then you have routing taking place, and these are the API keys and stuff like that. So gives end to end, and now he's already working on part 2, which will be live soon again on blog.kubesimplify.com. Is there a place I can join to? Yeah, I told you that. Is it similar to NVIDIA GPU? So NVIDIA DGX Spark is basically the hardware. It's a system. I can just show you that this is the device. This one. So this is the NVIDIA DGX Spark. This is kind of a GPU box which is there. So the GPU box has something which is called a unified memory architecture. It is called UMA. It is 128 gigs of unified memory architecture. It has CUDA cores. It has the GPUs, and you can access that. You can run models on that. You can do good inferencing on that. You can do fine tuning on that. I need obviously more boxes, so I need a cluster of 4 because I want to run the Nemotron 3 Ultra, which is greater than 500 billion parameter model, which takes 4 DGX Sparks. So if you want to run very heavy models, kind of, obviously you need more GPUs, and for more GPUs locally, you need more devices like this. And this would be very interesting. 4 DGX Sparks. You can then run 500 parameter billion model, which is at par at some of the things with Codex, Claude. So local LLM game is changing a lot, like a lot. So the next era you will be seeing in the next 6 to 8 months. Like before 6 to 8 months, it was very difficult to understand how the local LLM will catch up with the frontier models, that we see that are closed source. But now we see the gap is closing and closing and closing and closing. They're coming very close. You have seen GLM models, Kimi, and then DeepSeek is coming up again with more parameters. So we'll soon be seeing the 1 trillion parameter models. And these will be amazing at par that you can run in your own hardware, many data centers, many AI factories. I have been talking about that. This will change the game for organizations who want to host stuff. So yeah, now is the right time to learn about these stuff. And I keep on writing, different kind of things like Bondler, a new open source project by Runpod team, MLXCL, and then these general Kubernetes concepts and things. So it's pretty cool. And you can also contribute, by the way. So there's a write for us. You can write for KubeSimplify. There's a complete step-by-step guide. So if you see here, There's a step-by-step guide if you want to contribute to KubeSimplify as well. And yeah, we have all these folks, like Manoj is contributing to KubeSimplify, Shubham is contributing. There are many contributors, and we'll all learn together. So just help us spreading the word. That's the only thing. All right, I think Manoj will be back soon, and we'll be able to start in a few seconds back on our observability workshop, which is going really, really dope. So I'm so happy that I was able to plan this out with Manoj. Yeah, NVIDIA RTX Spark is the same thing. It's basically for the Windows laptop and collaboration with them. So it's going to be amazing as well. But I use it as the desktop as my machine as well, because it comes with Ubuntu as a base, Ubuntu base, and then they have their own stuff. And I use it as my day-to-day for my day-to-day work as well. I do some training on it. It is always running and it's fun. All right, so now we wait for Manoj. Once he's back, we'll start. I hope you are able to do the workshop as well. And a huge thanks to Ivan for the playgrounds. I and Ivan were sitting 1 a.m. last night, like this morning, and we kind of fix the playgrounds and make sure everything is working and things like that. All right, Manoj is back. So let's start with the workshop again. Over to you, Manoj.
Thanks, Ayam. Okay, so let's get started from where we were. So till now, what we did is we started with basic monitoring for Kubernetes. We tried to do Kubernetes top command to see live CPU memory usage. We moved to Prometheus so that we can save historical data, past data, and see the patterns, graphs, and everything. From there, we moved from Prometheus to basic OpenTelemetry Collector and build a metric pipeline. And in the pipeline, we moved one of the Prometheus job from Prometheus Server to OpenTelemetry Collector, Prometheus Receiver, which is equivalent of Prometheus full-fledged Prometheus Server. Actually, that's the core part of it. And we use Prometheus Remote Write, which is a part of Prometheus Server, but again a small component which came into OpenTelemetry Collector, which help us write back to the Prometheus database, time series database, which is another component of Prometheus Server. So when you did Prometheus Server,
you're not sharing anything.
No, I'm not sharing. I'll just summarizing of what we covered. Yeah. So now the next two very small workshops, very small hands-on. It's not as big as the first, second, but we'll try to build trace pipeline and log pipeline, because these are the three signals which are important one. We build the metric pipeline till now. Now we will build a trace pipeline first, and we will use Jaeger at the backend to see the traces, and then we will build a log pipeline and use an OpenSearch to actually see the logs. Okay, so let me share my screen now, and let's move to a very quickly the session. The PDF, few slides, and then we'll actually get onto the workshop. So I'll just share. Yeah, okay. So I hope my screen is visible. So we completed lab 3, we completed lab 4, where we moved Prometheus server. So this is what we did, right? So we copied configuration of Prometheus. We copied it to collector config. We added remote write and exporter and Prometheus receivers. We added the cluster role so that the role required by the collector service account to scrap data is there. And we are able to see those jobs coming to Prometheus backend and able to remove the Prometheus one, the one job we actually migrated to the collector as a metric pipeline. Okay, so now the next part is the trace instrumentation with OpenTelemetry. The first two one, the bigger one, they are the foundation set. We understand Prometheus, we understand Collector. Now we will see, just add the trace instrumentation and log collector quickly and see the whole three things working very well together in a single collector binary. So we'll talk about auto instrumentation. So we talked about Auto SDK in the past. As I was introducing OpenTelemetry. The SDK is an actually default implementation of OpenTelemetry APIs. These APIs or interface, this interface defines how you create. I will not say how, what you create and where you send. How you send. That's but the implementation is specific to languages, or you can build your own SDK. So by default, OpenTelemetry comes up with standard implementation of SDK for each technology, Java or Python or Go or any other language which you are using, even Node and other stuff, which you can directly import and add to your file, and everything works fine. You don't need to do anything else. You just want to download the SDK. Each technology has its own way of putting that SDK in runtime so that it gets ingested to your code and start working. Java one is basically is a hotel Java agent argument which you pass at the runtime when you start your application. At runtime, you put that SDK and start the process. Similarly, other technology has the way to do that. But what is required to do a standard setup is to just download that package and add to your application and start it. That's all. You don't need to make any code change, anything to your application, and everything works standard. And on top of standard, you can add on now. As and when needed, you can start adding. So what we will do now, the hotel demo application which you deployed already has SDKs added for each language. What it doesn't have is the endpoint which send data to the backend. So it is generating data, but it's not sending to anywhere. SDKs is there, auto instrumentation is there, it's creating traces, but it's not sending to anything, anywhere. You need to actually add that endpoint, and that endpoint is nothing but the collector which we deployed recently. Two things, we will, because this is a actually push-based model, the originator, the source has to configure where the data need to be sent. We will configure a couple of our hotel demo applications to configure that endpoint, which is our collector endpoint. And inside our collector, we will define trace pipelines, because even the collector is getting the data. If the pipeline is not defined, it is not doing anything with that data. So I will define the pipeline, and we will send that data to a Jaeger backend. Jaeger is also already installed as part of your hotel demo application. Jaeger comes inbuilt, so Jaeger is already installed. So what is left to our source application? Give the endpoint, define trace pipeline in our collector, define a Jaeger exporter, and send it to the Jaeger backend. So we will just configure hotel collector here and application, and data will come to Jaeger. So we'll see that. So this is what we are going to do. Our collector is already running. Now it has only metric pipeline. We will enable the trace pipeline by adding a Jaeger exporter and adding that Jaeger exporter to our trace pipeline. On the Kubernetes cluster, we already running some microservices. We will configure them with an endpoint so that they can start sending data to the collector. And as soon as exporter is configured, it will start sending data to the Jaeger. And we will actually use Jaeger UI to see those traces. So that's what we are going to do. Okay, so let's move to the lab now. Any question on this? Anything before we actually move to the lab? Okay, let me check on the chat also. Okay, so nothing. So let's get on to the playground now. Okay, so I hope everybody is able to see my playground. And if you see the README file, lab 5, it has the command what you need to run to configure it. If you are editing your file and your value file addition worked very well, continue to use the value. if we have moved to value-prometheus, you can, and now you want to edit, you pick that value-prometheus to your local directory and start editing it. And if you do not want to do both, you can pick up a file called value-jaeger, which is there in the repo, which has all the changes which I'm going to do currently. So you can actually pick up value-jaeger file and directly upgrade your OpenTelemetry Collector using the new value file, and it will do all the configurations based upon your convenience. You can do. Okay, so let me now do and edit my value file m/total collector and value. This is the file which I was working till now. I will open. This is the edited one. What I need to do here? What are the prerequisites? I have to add a Jaeger exporter because I want to send. So we are already added an exporter, Prometheus Remote Write, in our previous step. I will add another exporter now, which is a Jaeger exporter. Again, need to make sure the syntax is correct. So I will just add a Jaeger exporter. So Jaeger is actually an OTLP exporter itself. The name is what I will. So just because there are many exporters which actually use the native native exporter definition itself. They don't have their own dedicated exporter. Just like Prometheus Remote Write, right? This is a Prometheus exporter dedicated, but many use OTLP. OTLP is a standard exporter. So I'm using that, and I'm just saying /Jaeger. So what OpenTelemetry allow you, in case you are using the same exporter multiple times for different backends, but the same protocol, you can actually suffix it with /anything. So I'm saying I'm going to use OTLP only, which is being supported by many other endpoints, but this OTLP is dedicated for Jaeger. So I'm using it for Jaeger. So the configuration which comes down, this is actually Jaeger specific configuration. I say OpenTelemetry /Jaeger, and then I say endpoints. This is already deployed in OTel demo thing. When you deployed our first step in first workshop, OTel demo. So there is Jaeger service got deployed. So that's the name is Jaeger. OTel demo is my namespace, SVC cluster local 4317. So this is standard OpenTelemetry DSN name, service name, server DSN which I am using. And I'm saying TLS insecure because I don't have TLS set up yet. Jaeger is again a insecure endpoint as of now. So I did this. I hope all changes are correct. I'm not doing any mistake. Let me just reconfirm the alignment is okay. Okay. So now I have added an exporter. What about receiver? The SDK which we added in our application, and we will be setting the endpoint also, that is an OTLP format again. So our receiver is also an OTLP, which comes by default. I don't need to add. If you see receiver, OTLP receiver already exists. That come by default. So I don't need to add. The receiver already exists. It will listen to this port, this endpoint 4317, and my service will send data to this endpoint. We'll configure that after this. The next part is I just need to add it to the pipeline. So I will just say OTLP Jaeger. I will just make it copy so that I don't make any mistake. So I will go to trace pipeline. This is my trace pipe. Here it is. So I already have a receiver, but exporter is only debug. I will just add another receiver here, which is OTLP Jaeger. So I defined OTLP Jaeger exporter. I have added it into the pipeline. OTLP was already there as a receiver. I don't need to make any change. My application is already having an SDK as part of their package, so I don't need to add that. Auto instrumentation is enabled, no code change needed. Now, only thing left now is to edit my deployment, application deployment, to give them the endpoint of this collector, which I'm running currently, so that it start receiving data. So two things now. I will upgrade, and then I will also do that change in my application. So upgrade is same which we are doing already. I will not make any changes. Where is my upgrade? I'm upgrading here. Here it is. So I'm again using the value.yml file. I'm not, but if you are not making changes live, you can say value-jaeger. That's the value file which you can upgrade. Rest things remain same. upgraded. This time there are the change in that collectors and all. Hopefully pod will get restarted. Let me see. Yes, everything got restarted, working fine. Everything is up. Now what is missing is now to give the endpoint. So let me, and then if you go to the README file right here, so this in the lab 5, you have how I'm doing here. Okay, so I'm just setting up to the 3 of the services: front end, proxy, and add. These are the 3 applications. I'm setting what collector I have to send that up to. You can copy paste from here, or you can try with any microservices which is running. You can actually do kget deployment -n portal demo. There are many of them which are running here. I'm going to make changes to front end proxy, and add, because front end is the first level of calls. I just want to do that. I will instrument, or I will add a environment variable to these services which has endpoint value for our collector, so that they know. I mean, that's what how it works. Let me copy one of the command. You can copy it from the README. I will explain what I am going to do here. If you see here, so I'm saying set environment for the front end. Of course, demo. I'm saying hotel collector name. After that, if you see, hotel collector -OpenTelemetry Collector .observability.service.cluster.local. That's what, again, a Kubernetes service endpoint. Hotel collector -OpenTelemetry Collector. This is the service name which got created when we did hotel collector deployment, right? In the first step, that's the service name created. Observability is the namespace, service.cluster.local. So I did that set environment variable. So that way I am telling SDK, which is already part of this front-end deployment, that this is the endpoint to whom you have to send the data to. Edit it. I will do the same, exactly same thing for others. That's the beauty of OpenTelemetry Collector. So all the what you call semantics are actually same across all the languages. So I don't need to worry about which language. I just need to tell them through an environment variable that this is what you need to send the data to. Okay, I'm sending for the 3 of them. I mean, you can do try out for more. Maybe I can give you 5 minutes later. You can try out for more and see what is happening. Okay, this is done. Now what next? I need to see a Jaeger UI. Now, as part of a hotel demo, right, Jaeger UI is actually embedded. So you actually port forward this front-end proxy deployment. And there is a endpoint / I think API / Jaeger. I think I will give you that. I think it's there in the README. That's where the Jaeger UI runs. So it's already running. Let me do a port forward for hotel demo, and then we'll see the UI. So what I'm doing is, okay, let me see. So I'm just doing the port forward for front-end proxy service, 8080 port where it's running. I'm porting it to 8080. If you have already used 8080, use something else so that port conflict does not happen on your local system. And I'm doing -address 0000, which is required for this playground. I mean, if you are doing it on your own Kubernetes cluster, this may not be needed. Port forward is done. So what I'll do, I will just say expose HTTP port. What port I used? 8080. I think it's on, yes, control plane. I exposed it. I may have to do this. Okay, this is the link which is given to form 8080. I will click on this. So this is my application. I mean, we haven't seen that application earlier, but this is the application which got deployed. I mean, that's the UI of the application. It's a simple e-commerce site for some gadgets and all things. So that's telescopes and everything. But yeah, on this, there is a Jaeger UI which you can run, which is like /Jaeger/UI. So I'm just saying here /Jaeger/UI. So I just putting this. I hope yes, this is the one Jaeger/UI. So the URL which you receive, just say /Jaeger/UI, and you will see the Jaeger UI coming up. Yes, here it is. So this is something like lightweight storage for traces, just like Prometheus is a storage for metrics, and you will start seeing the services here. Front end, and add. These are the three I did. These are coming. You can play around. You can exactly run the same command, which I just a second. But where is my playground? Here it is. Wait a minute. So you can also run the same command which I run it here for any other microservice. You have checkout, you have cart, you have code, product review. There are many. You can pick up any. You can just change the name of this here. Instead of add, put some other service name. Rest of the things remain same. You just need to tell them what the endpoint is. Just it restarts, and you will start seeing in your Jaeger thing. You will start seeing this here. So all the traces have started coming here. So let's see what traces are coming and how traces looks like. I think there was one question earlier like how traces looks like. I'll just say front end. Just select the front end. I'll say all, and I say find traces. So there are around 20 traces as of now which got captured. So these are all their response time graph, which is coming the way. You can see down there are spans in each, 11 spans in this. This means one trace has 11 calls at this child. I will just say click on this. This is how the trace looks like, the whole flow in a tree structure. So the call started from front-end proxy. It went to the ingress. From the ingress, it went to the /API data call, the front end. It actually, if I click on this, you will see the details of this API call here. All the tags, all the processes. You will have a lot of attributes. It says it was a get call. Response time was 200. It was next.js library which is being used, and of course there's a response time of it which is coming at the top here, 5.47 milliseconds, which is being used. So that's the call which is getting. This is the data, and this is actually what is generating it. So this is the host pod which is generating it. It's running on the Linux system. Process of the application /app/server.js. That's the command which run. So if you see -require instrumentation.js, this is what the JS way of JavaScript way of ingesting a package, OpenTelemetry package. Similarly, this is like -- Java agent, which is actually the Java way of doing it. So you change that thing. So it's a node application. It's also pick up to the node versions which are doing. It also says there are some warnings. So yeah, there's a gap between the browser, the client, and the server time. So it's skewed some 8.60 milliseconds. So that's okay. That's fine. It's a demo stuff. So that's how you get everything for all the calls. So if you go below to the front end, it goes to the add, because add is also instrumented. We are getting add. So you're saying only front end proxy, front end, and add. Why? Because these are the only three things where we have enabled. This call might have gone to any other microservices also. I mean, to cart or anything else, because those are not yet have the endpoint where the traces need to be sent. It's not able to get it here. As soon as you set, you will also start seeing those microservices in this hierarchy also. That's how the Jaeger trace works. Again, I use Jaeger because this is available. But again, most of the observability platform backend, they support all the three signals together. That's where the correlation stuff comes in. When you have your different backend for metrics, logs, and traces, the correlation becomes difficult. When you have a single backend which holistically see all the three signals with all the labels and all the attributes, it will be able to correlate things and give you a story out of it. Yeah, so that's our lab 5. I just complete it here, and we'll just stop for any questions or anything on this. Okay, so let me see any questions or anything. Yes, so that's your localhost 8080 if you are doing.
Yeah, there's this one, Manoj.
Okay, there's no questions,
All,
right? Yeah, just
all
reading through the.
the last one, if you see by Kalyan, all these things will be coming natively via Datadog or Dynatrace.
Okay.
So instead of doing all these installation and stuff, why to go with Hotel plus Jagger then?
Okay, so Jaeger, I agree, it's a backend. You can use any backend of your choice, including Datadog. Hotel, I can disagree. No, I mean, if you are so see each vendor, I will not specify name, but each vendor had its own agents also, right? And there are vendors which actually do their own OpenTelemetry distribution also. So you will see vendor A, vendor B, vendor C has their own OpenTelemetry distribution. They add abstract layer on top of it, which make things easy. Yes, they do. You don't have to configure your own OpenTelemetry collector. Doesn't need to work on YML and all. But what if you are going to migrate from vendor A to vendor B? This abstract layer of vendor A will not work for vendor B. Everything has to be rewritten to a vendor B's abstract layer, and they are not compatible. But if you are working with an OpenTelemetry Collector YML, which is a basic, and working on that, the same YML, same config which you have created for vendor A will work as it is for vendor B. There is no migration required. So that's where the hotel, lot of people actually prefer initial hard work to create these OpenTelemetry Collector YML files, the config files, because they know this is one-time job. Tomorrow I move from vendor A to vendor B to vendor C, I will just use the same. But if you start using vendor's own agent configuration, even if it's an hotel compliant, there is a migration effort. So that's what it is all about. But yeah, backend wise, yeah, I'm using Jaeger because I don't have Datadog, to be very frank. Jaeger is a free, same the Prometheus is a free version, so I'm using it for workshop. But yeah, you can send it to any backend. Data can be sent to the Datadog or Prometheus or Jaeger or Grafana or any other backend. So you can do that. Yeah, Guru. So, I mean, my deployment, yes, it will be lost because I'm using a host path volume mount. I'm not using a persistent volume. If you are doing on your own Kubernetes cluster and you have a PVC, you can enable it for PVC. So my Prometheus deployment, my Jaeger deployment, both of them are using a host path volume. So as soon as the cluster is destroyed, everything is destroyed. Okay. Is there any other questions?
No.
Okay. So we'll just go again to our slide deck then. Okay. So yeah, that's what now we build a trace pipeline. So I know I have not shown you the manual instrumentation part, maybe something a little more advanced. Instrumentation is a little complex when you start doing it manually. Auto instrumentation is most of people prefer. Manual instrumentation is rarely done, especially if your use case is very unique and you want to even send some of the business level metrics, because the default instrumentation only gives you a technical metrics. I mean, the response time and all, but you want to track your number of orders or number of clicks or whatever it is. Those are business metrics. If you want to instrument for that, you want to use OpenTelemetry for that, yes, you can do an instrumentation and send it across to your backend to even analyze that. So you do that way. But yeah, so let's go to the next log collection with OpenTelemetry. We build a trace pipeline, we build metric pipeline. Now it comes to build a log pipeline now. Log is a little bit unique because this require, if you want to move to an auto native way of doing it, right? Just like traces, there is an auto instrumentation, right? Which you don't need to make a code change. You add an SDK and things work fine. Log does not have such capability. I mean, there is nothing like an SDK which will you ingest, and it will automatically start sending logs to your endpoint. I mean push-based model. It's not yet there. Future I don't know, but it's not yet there. So, and if you want to use this combination, you have to make a code changes. There's no SDK available. You make your code changes, make your log creation and ingestion OpenTelemetry native, implement those APIs, SDK APIs to send the logs. You can always do that. But many legacy systems have a huge log set, right? There are hundreds of microservices, millions of lines of code. There are millions of places where you say log.out, log.console, log.error, and all. Start changing that to start using an OpenTelemetry native way of is very huge task. And that's where lot of effort has been made to actually ease things out there. And that's where OpenTelemetry actually collaborated with those standard logging libraries. For example, Log4j for Java. 90% of the Java application use Log4j for logging. So they combined with that and they did Log4j changes so that Log4j can help you out to add those correlation stuff in that without making much of the changes there. So that's how it do. And from the log collection perspective, there's no push model. You made to make a code change where you can push logs to the collector directly. There is a workaround on an existing logging module. You can actually enhance or increment that to collect. So we'll talk about that now. Okay, so first let's see how Kubernetes log management works. Sometimes a lot of people confuse this. If I don't know, I mean, whenever you start cloud, right, there was a 12 principles of cloud native, right? That's the first thing which you read whenever you talk about. One of that principle was to write on console.out in a cloud native way. You do not write to a manual file or a custom file, right? Which was the case in the past when you run things in your host, right? In your self-hosted or in a VM or in a machine, we generally write that to a file. There's a log file, rotation of the log file happens, and we do all that stuff. In a container world, we generally write it to a standard out. And Kubernetes give you a functionality that it actually read those standard out and send it across to a host path. So that happens. There is a auto mount of a path to all the containers. All the console.out stream actually gets sent to that mounted path. This mounted path is actually a host path on the underneath node, and that has all your logs entry. So that's already available. That's how Kubernetes manage, and that path file you can use it for any purposes. I mean, and OpenTelemetry Collector actually use this path to collect logs and send it to the backend. So you are not collecting it from the application directly. You are actually making use of a Kubernetes functionality which already exists to read logs from the path and send it across to the backend. So that's what this visual actually indicates. You are writing path to standard out in the left hand side. First step. Second step, it's written to the container file system, and that container file system actually is a mounted path from the host path. It gets written to a host, and from that host you actually start reading. The collector will start reading. So how we'll do it? Through a file log receiver. So what file log receiver do? It actually start reading those path on the node and start actually reading that file and start putting it to the collector. Now, the logs written to a particular node is only for the ports which are running on that node, right? So every node has its own path, and it keeps logs of the node ports which are running on that particular node, only that. That means I need only daemon set. If I run a deployment, right, and that deployment is running on a particular port, particular node, so it can access file system of that node only through a host path mount again, but it cannot read a file system of the node 2 or node 3. So you will not receive all the logs together. That means to use file log receiver, you need a daemon set strategy only. Deployment strategy doesn't work. And that's one of the questions which came, right? What use cases, what architecture you use. For using file log receiver, you need a daemon sort. Deployment doesn't work. Okay, so that's one of the use case for daemon set strategies, daemon set architecture. Okay, so this is a difference between traditional logging and OpenTelemetry native. As I said, in an OpenTelemetry native, you actually add an SDK, logging SDK. You make code changes to create log records, add attributes, and actually make an API call, which is an hotel SDK standard API call to send data to a backend, to a collector. So you don't need to write a file, but that requires a lot of code changes. And the left-hand side is the traditional logging and how collectors actually help you collect the log with the traditional logging itself without making code changes. So your application is there. It's writing to a container path. That container path is nothing but a mounted host path. That host path got the data. Collector on each host mount the same path now on its own system. So it can read that host path through in its own process, and then it start reading that file and start sending it to the backend. So that's what the file log receiver do. Now, what that means, my daemon set which I am deploying will has to have a mount added for that host path so that it can read those files. So that's what we will do in our workshop. We will add mount paths for that particular. We'll add file log receiver to our pipeline, and then we'll to our receiver definition, and then we update our pipeline to the file log receiver. We will add an OpenSearch exporter. We'll add an OpenSearch exporter, and then we'll add it to our pipeline in the exporter for the log pipeline section. So OpenSearch is again deployed as for you in Hotel Demo. Hotel Demo come with an OpenSearch. So Hotel Demo is a complete package. I mean, it actually come up with your Jaeger. It comes up with your OpenSearch for log. It even come up with Grafana deployment, which I disabled because we didn't have that much playground size to even deploy a Grafana LGTM stack. But it comes with a Grafana installation also. So if you do a default installation, it will actually deploy the Grafana also. But if you see in the value file of the first workshop when we deployed Hotel Demo, I explicitly disabled LGTM because we didn't have that. Our playground size. So I will show you that too, but maybe you can look at yourself also. But let's go into log section now and try to create a lab 6 where we are now going to add a log pipeline into our collector. Again, I will work on value file. My value file is working. Luckily, I'm lucky that it's working as of now. I'm not making any errors. But if you are worked on the value file working, you can continue to do so. Otherwise, you can pick up, I think it's a values-file log. So that's the last file which has everything. Whatever the workshop we are doing, whatever the changes we are doing, it has everything on that. So let me see the file name also. I mean, I'm sure we should not be, hopefully I'm mashing it correct, but I will check in the path, the last file.
Manoj, we are on the slide deck.
Yeah, I'm just
Okay.
coming that. So the last file which you are going to use is value file log. So this you can pick up. This has everything. All the changes I have made till now on all the files. This file log has everything. If you are making changes manually, you have already reached up to value Jaeger, and you can keep making changes for file log also with the same value file itself. Or you can directly use this and upgrade for this, and it will work fine. Okay, let me go to my workshop again and let me edit my ham/hotel collector /value file. This is the file which I'm making changes from my lab 3, lab 4, lab 5, and we are making change for lab 6 also. What we already added Prometheus. We already added initially the Prometheus receiver. Inside the exporter, we added Prometheus Remote Write and OTLP Jaeger. Now what we do, we will add file log receiver inside the receiver section, and we will also add OpenSearch exporter, and then we'll make changes. Or of course, we have to add mount point also, because it's not the typical way. We are reading it from the host path, the logs. So let me first add. You can take it from the file also, or you can. I mean, this is a little big configuration, so I'm not typing it out. So I'm just adding the Filelog receiver first. So this is my Filelog receiver, what it's saying. Okay, I have to correct. Is this correct? Or yes, this is correct. So I'm saying my Filelog receiver, read it from this path. This path should be there, and this is the path which I'm going to mount from the host. I'm saying start at beginning and start from the beginning of the file. I mean, if you are enabling these config and you already have a file which has already have few GBs of data, how you want to start? You want to start from the time when you had deployed this collector, or you want to start from the starting? You want to get the historical logs also. So you can set that. Include file path. I'm saying, okay, include the file path. That means in the labels, the file path should be added from where this logs are being read, and you add the file name also. So this is just to give more insights, right, from which file it's coming. If you see the file, right, the path has a lot of data in it. It has port name, it has container name, everything is a part of the path. If you have worked with Kubernetes logging, right, how logging is managed, the path itself has a hierarchical structure. So namespace, so if you see the hotel-demo, this is a namespace. So you have ports, namespace, the port names, the container names, everything in the path, and finally a text log file where the logs of that particular object comes in. So I am adding this. I'm also adding some operator. The operator is processing. I mean, before you want to send the logs to the backend, you really want to do some processing on it. And of course, there are processors who can do this, but the Filelogs comes with its own processors, I mean, own capabilities of processors in it. So what I'm doing is type is container. Wait a minute, I think yes, and type is ADD. So I will not get into a lot of details into that, but it's actually saying for each container, you add an attribute source as Kubernetes. So whatever the logs are coming, you are adding. If it's a container logs, then you can actually adding at source Kubernetes into it. Just a simple thing. But there are operators. There are a lot of operators Filelog has. You can get the message of the log, take out some of the entries of that log, convert into some attributes. You can, for example, error. What you call it, your message might be having error label, critical or warning or message or info, whatever. You want to take that out and make it as a label. Making it label means you can actually filter on it in your backend. Your backend will give you a power to filter on it, right? Otherwise, it will be all regex expressions you do, which is really costly. So, or you can even say the index on it, so that you can do that stuff. So that's the power. So I added a receiver file log. I hope nothing mistake I have done, hopefully. And I will also add a exporter, which is an OpenSearch exporter. So I've already added a Prometheus exporter earlier. There is an OTLP exporter also there. Okay, this is receiver. This is not exporters. I will just go down. Here is the exporter. So I added Prometheus Remote Write and Jaeger. So I will try to add one more here. Let's see. This may be an easier place from thing. And I will add an OpenSearch exporter. Wait a minute, where I'm missing. Just a second, guys. I think I'm missing OpenSearch exporter definition. I may have to read it from my file on the value file log stuff. So yes, I have the OpenSearch. Let me copy it from there. Okay, so I'm adding my OpenSearch exporter. So this is similar. Again, I mean, you put an endpoint. OpenSearch is already running in my hotel demo. So I'm just putting the endpoint of that through the Kubernetes service URLs, OpenSearch/hoteldemo/service.cluster, and log index. I mean, if you have worked with OpenSearch, you know that OpenSearch keep data in a index thing, right? So you have to create. So I'm saying create that index hotel demo logs. It's a OpenSearch specific configuration because I'm using an OpenSearch exporter. So I'm just saying log index into hotel demo log. So this is done. Next is I want to add into the pipeline of logs. So I just say receiver, I add a file log, and in the exporter, I want to add OpenSearch. I hope my spelling is correct. I'm not using any capital here. All is, yes, all small. OpenSearch. I added an OpenSearch here. So this is done. Now, one thing is missing is now the volume mounts. I mean, it will read it from this file, but this file is actually in the file log definition, what we mentioned, right? I can read this file, but this file is actually on the host path, not on the things. It has to read. I have to mount that. So Kubernetes is writing on it from all the containers, and again, the same volume mount is mounted on my daemon set, and it will read it from there. So this is hem value, right? So I'm just asking hem to do this volume mount for me. So just toward the end of this file, where I did the cluster log, I'm just mentioning, okay, do this volume mounts whenever you are running this or creating this daemon set. Let me do that. Okay. So I'm saying get this volume is a host path. In the host, it's varlog containers. That's what we talked about. You just use this host path and mount it at varlog ports. And that varlog port path is being used in my file log here. The receivers here, varlog ports. After that, there is a subpath hotel demo hyphen and all. So that's the metadata regarding all the objects, namespace and all. Hopefully, I have done things correct. I've updated. Let me upgrade again. So I have this upgrade. I'm just hoping this works fine. It's a little more complex, but let's see. It's updated. Let's see. Yes. Okay. The first one is still starting. Okay, started. So volume mounts and everything is being done now. Volume is mounted. File log is running. OpenSearch is running. So let's see how we can access OpenSearch stuff. So there is a little tweak here. I mean, it took me some time to actually run that OpenSearch. Let me see if I'm able to run it now or not. Let's see. So OpenSearch is, I think there is a path. Let me see in my where the OpenSearch. Let me see if I have mentioned this in the README or not. Yes. So OpenSearch is actually the OpenSearch which got deployed is just a backend. There is no front end. I was just recalling what challenge I faced. So to use that backend, you need a front end UI. So front end UI you need to deploy so that you can actually able to see. So the data is going to OpenSearch now to the backend, but there is no front end to it. You can always access OpenSearch through an API calls. That's what hotel demo people do. But to make things easy, I just added in the lab 6 in the README, right? There is a hem repo add and hem repo install command to install the OpenSearch dashboard, the front end of the OpenSearch. So I will just deploy that. I'll just adding an OpenSearch repo, and then I am going to install OpenSearch dashboard. If you see, I'm telling it that the backend is OpenSearch 9200. That's where in the same namespace, it's actually in the hotel demo. It's running at this service. So I'm just telling the front end that, okay, this is the backend. You have to connect to this backend and work out. This done. Hopefully this will work. So I just need one more command to set the environment. Another tweak here. because OpenSearch by default accept user ID password authentication. The OpenSearch, which the backend which is installed in Hotel Demo, is authentication less. There is no user ID password. So I need to disable it for the dashboard also. So I'm just setting that environment, and I'm saying disable security dashboard plugin. So I'm disabling that plugin so that it doesn't get into the loop of getting user ID password, because my backend does not support that user ID password backend anyway. So I will just do that. This is updated. Hopefully this works. Let's see. I will again do the port forward. Now for the open dashboard service. So I'm doing a service dashboard OpenSearch dashboard. This is get deployed through the Helm chart which we deployed now. 5601 is the port where it got deployed, and I'm saying do the port forward. Okay, so it's still pending. It may take some time. I think the port is not yet up. Okay, it's going up now. Forwarding is successful. Let me see the OpenSearch dashboard now. So I will see 5601 because that's the port I'm exposed on now. 5601, there's a new URL got created. I will just click on this. I share this tab. So let's see if OpenSearch comes. It's the last leg of the session. So hopefully this works fine. The OpenSearch was the difficult part when I was trying out, right? There was a couple of issues which came in, but let's see. My port is still warming up, I think. Okay, this is still gone down. Why? Failed to execute port forward. Why no suitable address found? So let me see if my dashboard runs fine or not. Okay, get ports minus name and order demo. And I'll just grep for OpenSearch. Okay, my port still not came up. The dashboard ones, I really don't know here yet, but let's wait. I don't think I can start debugging, but let's see if this comes in. Let me do quick look at the logs. It is still warming up. There is no error, so hopefully it will come up. Oh, it came up now. Took some time. Let's do the port forwarding. It's worked. Let me go here and just refresh this. Hopefully we'll get some OpenSearch UI. Yes, we came in. So now the data is coming, and again, if anybody is aware of, okay, this is the first time I've installed, so it's do some initial stuff. So I'll just say explore on my own. I am not adding the data. I'm just saying explore on my own. So I'll first say if index got created or not. I'll just get into indexes here, index management. So inside the index management, I go to indexes, and I see there is an auto demo logs. This got created now. There is an 8.9 MB of data also came in. So yes, data is coming. Data is getting populated. Let's try to discover this data. So when you discover it, index pattern is what OpenSearch require. Without index pattern, you cannot search. So my hotel star, that's my index name on which I want to discover on. So I just take my timestamp as a time field. It's created now. I will be able to discover. So let me go back and say discover again. And yes, the logs are coming to the OpenSearch. These are the logs which are coming.
Manoj, we are
Yep.
still seeing your expose screen.
Okay. I see it's shared this tab. Okay.
We are seeing only the expose HTTPS screen.
Okay, I don't know. I actually say share this, but let me stop sharing and
Or maybe
share it.
maybe it's froze for some reason.
Okay, let me. I will just stop sharing and I will share again. I don't know why my sharing got hung. It seems like. So let me share again. So I will just discover. Okay, is it Now visible, the OpenSearch web.
Yes, now you can see.
Okay. So I did that port forward. I got the link. I moved to that link the same way we did in the past. What I did here is that initially you will not see this page. I think I did a couple of steps here. So you go to, so first there will be a pop-up, or you will say discover by your own. I mean, say add data or discover your own. So just a discover your own, that the pop-up will go away and you will see come to this page. In this, you do an index management, indexes, and you will see there is an index. That's what we mentioned in our file log receiver that got created. And this is 9.7 MB total size. The data is getting added. That's true. Then you go to discover. When you say to discover, you will not see this. It will ask you to create index pattern. So you create a new index pattern and mention that index name, hotel star. I mean, you just say a regex there, hotel star, and go to the next, and it will ask you what is your time attribute. So if you see the drop down, you will say add timestamp. That's the attribute which is coming here. Select that, create, and then you will actually come back again and do the discover here. So as soon as you see discover, you will be able to see this page now. So in this page, if you see the two things which we do, right? I say the file name and the file path should be part of the attribute. So you will see there's the file name, and the file path. They have become part of the attribute of this, and you can able to search on this. If you see here, var log ports, this is my port name, which become part of the path. And this is my container name inside that. Wait for Kafka, that is the container name. And then there is a path. So you get a lot of metadata in the path itself. The port name and the container name, everything is, and hotel demo is the namespace. So path has namespace underscore port name / container name / file number, how many files are being written. That is 0.log. That's what it is. It gives you some kind of a detail. You can always put more operators in the file log. You actually parse this path and make namespace and this port name as part of the attribute itself. So that then you can actually start filtering on, give me the logs for this particular port. That query can be answered because this name actually become part of the attribute itself. So that's a lot of other things which can be done. Okay, this is already there. I mean, this is coming by default also, the port name and the namespace name. Yeah, so that's all I have for this workshop. And I stop here. If anybody has any questions or anything on this, how you create your file log or the log pipeline actually. Okay, so that was our lab 6, which we did. And we are only left with the summary. So I'll just quickly go to the summary and maybe then we will open for question answer for some time as committed initially by SAM. So we'll do that. So what we did in the overall things? We started with Prometheus, where the basic stuff, and then we moved to OpenTelemetry Collector and we build basic metric trace and log pipelines. For metric, we migrated one of the Prometheus jobs to the auto collector. For traces, we already had a auto-instrumented applications. We just configured those applications to add an endpoint where the data should be sent because this is a push model. We enabled collector to add Jaeger exporters and also configured the pipelines, the trace pipelines to add the new exporter. Similarly, for the logs, we understood why logs are different from the other two and why we are not directly pulling or pushing log information directly from the application because of the complexity of code change. So there's an alternate way. There's a middle layer, which is actually a Kubernetes layer, which actually put these logs into some host file path. And we actually exploit that information. And on the demo set, we mount that host path and read it from there instead of getting it from the directly using a file log receiver. We use OpenSearch exporter for that, and we moved all the data to the OpenSearch and actually saw the navigation of OpenSearch too. So that's the summary, whatever we do, and that graph tells you what we built today. So yeah, that's the overall and maybe we can now open for any questions, queries, or anything. The repo
Awesome.
remains public. Workshop repo remains public, so you can always clone anytime, and you can always try out all the steps. Steps are clearly mentioned. Yeah, over to you,
Yes.
Sam.
What will happen is, I will first of all thank you so much, Manoj, for these wonderful 4 hours. And what we'll do is, obviously, the recording will be shared on KubeSimplify's YouTube channel. It will be free for everyone anytime to go and do this workshop hands-on. If anyone who attended in the beginning, they missed some portions, they can go back, revise some of the things, and then do the workshop. I'll make sure the GitHub repo and the slide deck is available for everyone. I'll put the links in the description of the video as well, so that everyone can watch it. And it was like an amazing session. That's what the learning these days is about. It's about the hands-on learning, and that's what we try to focus in this particular workshop. Now observability is a very big domain, and there are so many things to cover. Like earlier, when initially we were discussing, Manoj and I, so we were thinking that we might cover the LGTM stack, we might cover some of the other pipelines, but I wanted this more from a beginner's perspective, because everyone kind of tells, Kube Simplify has less beginner level content. So I wanted something, starting from very scratch, but at least obviously you should know Kubernetes. And for that, we have a lot of good workshops. But this is something, if you want to learn observability from scratch, you should be able to do that. That was the whole concept, the whole mind map. And then Manoj came up with the idea. We came up with the labs, we came up with the plan, and we are after 4 hours. We have concluded the first workshop. Why I say the first workshop? Because we do intend to do another set of workshops, but it totally depends on the response. Now, my request, and same from Manoj as well, to you is, whosoever joined the workshop today, please go out there on LinkedIn and X or whatever platform that you use. Please do share about the workshop, your experience, how amazing it was. Tag Manoj, follow him, and send him a request as well. Please tag him. Then only he'll feel motivated. So once he feels, and the response was great, so many people tagged him, that's a victory. And after that response, we'll definitely come up with the second one. And obviously, since this was the beginner one, next one will be more advanced one, like intermediate kind of level. We'll try to go into the LGTM stack and all the other things. Manoj, if you can share your LinkedIn also with me, I'll put that in the chat as well. You are on mute. Manoj, you are on mute.
Yeah, I was saying, let me share my screen again, because last slide has a QR code. I think I didn't show
Yeah.
that.
Please do that.
Yeah, so just give me the.
And we were like, so many people, I didn't expect so many people join in and stay till the end. Like, we have almost 50 people who are staying till the end, which is amazing. We do not even get that response when we do meetups. Like, obviously 4 hours, I know, is a very huge commitment on a weekend. So huge thanks to you for staying, committed, and that's what gives you an edge. And also, we'll keep doing more workshops. There's a service mesh workshop planned. I will be doing the AI series, the local LLM series, the video series also live. So there are a lot of things that we'll be doing. One last question that we'll take, Manoj, is by Hitarth, is, how could my customers see that data on my Prometheus running? Basically, the question is for customers. How could they visualize their data?
Okay, so two things. Depends on the need. If you have a local Prometheus, you can always expose it to load balancer. RD DNS is the standard how you expose your workload of a Kubernetes to an external thing, right? So you have today we ran Prometheus server as our first workshop. I did port forward for the service, but you can always change that service to a load balancer, and you get the URL, and that URL can easily be used for your mapping, for DNS mapping and all. You can do that. So that's the one way of doing. And then Prometheus has a very basic visualization tool. I mean, we already seen the graph in first workshop, right? We're seeing the graph. If you want to go a little more advanced, do Grafana installation. Grafana has Prometheus data source as a plugin, and that may be one of the things which I might want to show in the next workshops also. So Grafana has a Prometheus plugin, Prometheus data source. Same Prometheus which you are running currently, you just give the endpoint of this to Grafana, and Grafana can start querying your Prometheus data, and Grafana visualization is very strong. I mean, it's a huge set of things for visualization, and you can start creating graph on that. And then Grafana endpoints can be shared with your customer. Grafana also support your SSO. So you can always configure with your AD or any of your authentication mechanism, create your customer user accounts or end user accounts, and they can log in and start using it.
Awesome. So I hope that answers. Well, we are like we planned it for 3 hours. It already went 4 hours. Thank you so much for the extra time, Manoj. And I hope we covered what we intended to cover. I'll put all the links and everything in the description again of the video. Thanks to Ivan, my friend, for the playgrounds. So a huge thanks to Ivan as well. The recording will be available on YouTube. Again, folks, please do tag Manoj, connect with him, and get show your love for the stream. Thank you so much, everyone, and hope to see you soon in the next stream. Bye. Have a nice
Thank
day.
you.
Have a nice
Thanks,
week.
guys. Bye bye.